All right, people. I believe everybody is doing great, nice, and absolutely fine. So, please tell me in the chats if I'm perfectly audible, visible to each and every single student. And one more important thing. Make sure you smash the like button, okay? Because liking the session means marking the attendance, okay? And marking the attendance is extremely mandatory when it comes to this particular session, okay? And let the people join. We will start the session accordingly, okay? And one more important thing I just want to tell you in this particular case, my dear friends. What is that? That is, I will be showing you, we say, top 100 questions, and not just the questions. We'll be revising the concepts, whatever the concept is involved in a particular problem, okay? If there are multiple concepts involved in a problem, we'll be revising all of those. So basically, this will be the concept revision through problems, okay? That is the goal that we have in the today's session. That is the goal we have in the today's session. Okay. And before that, guys, is everything perfectly fine? Let me know in the chats. Everyone means everyone. Then we will move on to the session. Then I'll start the session. And make sure you note down each and every single thing over here. Keep that thing in your mind. Keep that thing in your mind. Okay. Yes, that's very great. That's very great. Let's start the session. Okay, let's not waste the time. We have first question over here in front of us, okay, on the screen. That is a mass at rest, okay, a mass at rest explodes suddenly into M1 and M2. It says that we have got a mass, okay. Let's suppose this is a mass, okay, and this mass is at rest. It explodes. Okay, it explodes. We say this mass explodes into M1, okay, and M2. Let's suppose it's a bomb. It explodes into M1 and M2. Everybody knows that when it comes to the case of explosion, we say this mass, this portion of this particular mass will go from this side, let's suppose with a velocity v2, and this will go from this side, let's suppose with a velocity v1. Okay. And my dear friends, further it says that ratio of masses is given as 2:3. Okay. Find the ratio of their de Broglie wavelength, lambda 1 by lambda 2. We are supposed to find if this mass comes in motion, it will have de Broglie wavelength. We are supposed to say this mass will have the de Broglie wavelength. What is the value of lambda 1 divided by lambda 2? This is what we are supposed to say, because de Broglie's concept, what does that say? If there is a particle which is moving with some velocity, it has de Broglie's wavelength, and de Broglie's wavelength, that is equal to, we say, h divided by p, where h is Planck's constant, p is momentum. Now everybody of you must know that. Listen guys, when it comes to the case of explosion, we say initial momentum in this particular case is 0. Why? Because this body is at rest. Final momentum also should be 0. Okay? Because there is no net external force, so we assume here net momentum is conserved. Initial momentum is equal to final momentum. Now guys, if I say in case of explosion, momentum is conserved. Okay, in case of this explosion, momentum is conserved. Take a look. Guys, if momentum is conserved, we say this p is conserved, this h is constant, this is constant, this is constant. Can I say this lambda will remain unchanged? This lambda will remain unchanged. Simple concept you can use over here. So I can say lambda 1 divided by lambda 2 will come out to be 1:1. Will come out to be 1:1. Okay, because momentum of this will be equal to the momentum of this. Okay. Then only net momentum will remain conserved. Final momentum is equal to initial momentum. So here, final momentum of this M2V2 will be equals to M1V1. So finally, momentum is conserved. Okay. H, Planck's constant, is constant. So I can simply say, sir, lambda 1 divided by lambda 2, it remains unchanged. It will be 1:1. Okay. Let's move on to the next one. Light of wavelength 500 nanometer is incident on a matter of work function 2.28 electron volts. We say this is a metal over here, okay, and light of, I would say it has got wavelength, lambda is given as, that is 500 nanometers. It is incident on this metal surface, and work function of this metal surface is given as, that is 2.28 electron volts. Okay. Now you tell me one thing. Whenever light falls on a metal surface, we know, sir, electron is ejected. This is the photoelectric effect. What does photoelectric effect say? When light falls, when photon falls on a metal surface, electron is ejected from the surface. Okay. Now, you tell me one thing. Could you please tell me what is the energy of this photon which is falling? We are supposed to say the de Broglie's wavelength. Okay. When this electron comes out, what is the de Broglie's wavelength of this electron? That's what we are supposed to calculate. First and the foremost thing, let's calculate the energy. Guys, if you know the wavelength, you can calculate the energy of a photon. I have told you in the modern physics, if wavelength is given in nanometers, okay, if wavelength is given in nanometers, which formula I am supposed to use? 1240 divided by lambda. Lambda is 500. So this is the formula that we use in order to calculate the energy of a photon. If wavelength was in angstrom, then I would have said 12400 divided by 500. Okay. Now in this particular case, this will come out to be 2.48 electron volts. Now this is the energy of photon. When this energy of photon falls, electron is ejected. Now can I use photoelectric equation? What does that say? That say energy of photon is equal to work function plus kinetic energy maximum. Now can I write over here, what is the value of energy of photon? That is given as 2.24 is equal to, 2.48 is equal to, what is the value of work function? That is given as 2.4. Okay. Then we say kinetic energy plus, I can say this is 2.4 electron volts plus, I would say kinetic energy. Now 2.48 minus 2.4, I can say this will be 0.2. I would say electron volt will be the kinetic energy. So kinetic energy came out to be 0.2 electron volt. Now, my dear friends, if you got the kinetic energy in this particular case, when you know the kinetic energy of a particle, you can find the de Broglie's wavelength. Which formula? Guys, lambda is equal to h upon under root of 2mke. How many of you do remember this? I have told you this in the 50 concepts also. Top 50 concepts also. So can I write over here lambda? H is Planck's constant. What is the value of Planck's constant? 6.6 into 10 raised power minus 34. Upon, we say under root of 2m. M is the mass of electron. This electron which is coming out, okay, that is 9.1 into 10 raised power minus 31 kgs multiplied by kinetic energy. What is the value of kinetic energy? 0.2 electron volts. So if you have to convert electron volts into joules, we multiply with 1.6 in 10 raised power minus 19. So I would say 0.2 into 1.6 into 10 raised power minus 19 joules. Okay, something like this. And solve this, the answer will come out to be, that is 2.8 into 10 raised power minus 9. Okay. Okay. How much? Yes, 2.28. Yes. 2.28 electron volts. That's why 2.4 minus 2.48 minus 2.28. That's why we are getting 0.2. Okay. So you are getting in this particular case, this one. Now tell me in the chats, is this crystalline clear to each and every single student? Let me know in the chats if this is crystalline clear to each and every single student. Everyone means everyone. And if you have not liked the session yet, I would want you guys to smash the like button. Everyone means everyone. Is this crystalline clear? Let's move on to the next one. Okay. First, we have some questions from the modern physics only, then we'll move on to the rest of the chapters. Now, in this particular case, it says that the de Broglie's wavelength of a particle accelerated with potential difference 150 volts is 10 raised power minus 10. There is a particle which is accelerated we say delta V. Delta V is given as 150 volts. There is a particle which is accelerated with this potential difference, and its de Broglie's wavelength is, I would say, 10 raised power minus 10 meters. 10 raised power minus 10 meters. It is, if it is accelerated by 600 volts, okay? If the same particle, if delta V is 600 volts, okay? Its de Broglie's wavelength will be, okay, lambda dash will be in this particular case. Now tell me, guys, quickly in the chats, let me know the answer of this one. Quickly in the chats. What is the answer? Simple concept over here, guys. When it comes to, we say, when it comes to the de Broglie's wavelength, what is the formula? Sir, H upon under root of 2m q delta V. This is the de Broglie's wavelength in terms of potential difference. Okay. This is the de Broglie's wavelength in terms of potential difference. Yes. Now, my dear friends, if it is talking about the same particle, so we say Planck's constant, H is constant, mass is constant, charge is constant, okay? All of these are constant. Why? Because his de Broglie's wavelength of a particle accelerated with 150 volt potential difference is 10 raised power minus 10. If the same particle, if it is accelerated with 600, the same particle means mass is same, H is same, Q is same. So can I say this lambda will be inversely proportional to under root of delta V? It only depends upon this. Okay. Now, my dear friends, can I say, guys, lambda 1, that is lambda, divided by lambda dash, this divided by this will be equals to, what is the potential difference when you have this de Broglie's wavelength 150? So it will be 1 divided by under root of 150, because this is inversely proportional to this, upon 1 divided by under root of 600. So you can write it like this. This will be under root of 600 divided by 150, something like this. Okay. Now, 1s are 4s are. Root 4 is 2. So I can write over here, this lambda is given as 10 raised power minus 10 divided by this lambda is equal to, here it is root 4, it will be 2. So lambda will come out to be 1 divided by 2 into 10 raised power minus 10. 10 raised power minus 10 means angstrom. So 1 by 2 is 0.5. Yes. So I can say lambda will come out to be 0.5 angstrom. Okay. 10 raised power 10 means 0.5. That means angstrom. Okay. Let's move on to the next one. An electron of mass m accelerated through a potential difference V has a wavelength lambda. This already we have solved previously. Okay, an electron of mass m, okay, you have got an electron of mass m is accelerated through potential difference V, has a de Broglie's wavelength lambda, The de Broglie's wavelength associated with the proton of mass m with the same potential difference will be. I guess we have solved this. Do you want me to show this question? Okay, we say, let's suppose for an electron, okay, what is going to be the de Broglie's wavelength? That is H upon under root of potential difference is given 2m q delta V. Q is E and delta V is V. 2m q delta V. Q is the charge of an electron, that is E. Okay, V is the potential difference, okay, with which it is accelerated. Now, if we talk about a proton, for a proton, can I say de Broglie's wavelength for a proton? It is going to be H upon under root of 2. Mass of electron is small m. Mass of proton is given as capital M. If you check over here, mass of proton is given as capital M. Charge on proton is also E. Here it is minus E, here it is plus E. Okay. And then we say delta V. Now, guys, when it comes to the lambda E divided by lambda V, lambda E divided by lambda P, it will come out to be, guys, it is H divided by under root of 2MEV upon H divided by under root of 2MEV. H and H will cancel. Root 2 V V E E. So it will come out to be under root of m divided by small m. Okay. Lambda of proton we are supposed to find out. So can I say lambda of proton will come out to be, take it over there and take this over here. So this will be under root of small m divided by capital M into lambda of electron. Okay, lambda of electron is given as lambda, small m by capital M, option B. What about this one? What about this one? What about this one? This was asked in NEET 2016, IIT 2021. These are the important questions, guys, okay? The ratio of the de Broglie's wavelength associated with the electron and the wavelength of the photon. I'll directly show you. See. When it comes to an electron, lambda of electron is h upon under root of, okay, here it is given energy, in terms of energy. We have got an electron. Okay, we have got an electron. And for electron, we say de Broglie's wavelength is h upon 2m. We say kinetic energy. Kinetic energy is given as E. Okay. When it comes to a photon, guys, energy of a photon, this formula you know, hc divided by lambda. This is how you find energy of a photon. From here, you can find de Broglie's wavelength of a photon, that is hc divided by E. Now it says, an electron and a photon have the same energy. Whatever is the energy of photon, same as for the electron. The ratio of de Broglie's wavelength of the electron and the wavelength of the photon. It says, find lambda E divided by lambda pH. Simple, bro. It is h divided by under root of 2m into E upon this hc divided by E. So you can write it like this. Lambda E divided by lambda pH, it will come out to be, that is h upon under root of 2m into E multiplied by E upon under root of E upon, I would say hc. So h and h will cancel. Okay. Further, we can write over here, this is E. Okay, just do one thing, guys. Just do one thing. Multiply with root E and divide with root E. Okay. Now this root E and root E will cancel with this E. Now what remains over here? This will be 1 divided by C, and then it remains root of E divided by 2m. Root of E divided by 2m. 1 by C. Okay. 1 by C. E divided by 2m whole raised power 1 by 2. This is the answer, because value of root is 1 by 2. Okay, this is a very important question. Okay, tell me the answer of this particular question, guys. Let me know the answer of this particular question. What is the answer to this question? Everyone means everyone. Tell me. The angular momentum of an electron in a hydrogen atom is proportional to, where R is the radius. The angular momentum of an electron in a hydrogen atom is proportional to. Guys, when it comes to the electron which is revolving in the hydrogen atom, everybody knows that this is the center, this is the electron. This electron has got mass m. It revolves around the nucleus. This revolves around the nucleus. And my dear friends, this is the radius r and this is the velocity v. How much is the angular momentum of an electron if it is revolving here? Use the simple angular momentum formula. You say, sir, L is equal to mvr sine of theta, and sine 90 I'll write over here. This is the general formula, mvr sine theta. Tell me guys, see. mvr sine theta. And what is the angle between r and v? That is 90, sine 90. So angular momentum is mvr. Now, lot of students in this particular case will say, sir, this angular momentum is directly proportional to radius. Okay. This angular momentum is directly proportional to radius, which is not in the options. Okay. Okay. What is the angle proportional to r? Okay. It is not. Now, guys, in this particular case, why isn't it proportional to radius? It will be proportional. See, what do we say? If mass is constant, velocity is constant, then we can say it is proportional to radius. Otherwise, we cannot say. Okay. Here, velocity will be different. If velocity is different, radius is different. Okay. In this particular case, listen to me very carefully. My dear friends, if I say here, when it comes to the angular momentum, it depends upon velocity as well as radius. Now tell me, how many of you do know that what is the velocity of an electron or radius of an electron in nth orbit? You will say, sir, radius of an electron in nth orbit is r naught n square divided by z. Okay. Radius of an electron in nth orbit is r naught n square by z. So can I say z is constant? If we talk about hydrogen atom, z is 1, it is constant. R naught is constant. So I can say r is proportional to n square. Yes. Now one more thing, guys. We know V is equal to V naught Z divided by N. This is the velocity of an electron in the nth orbit of the hydrogen atom. Now here Z is constant, V naught is constant, so we can say V is inversely proportional to N. Now if you do squaring on both sides, so we say V square is proportional to 1 by N square. Call this as equation first, call this as equation second. Now what I want you guys to devise is, what I want you guys to do is multiply first and second. Multiply first and second. Multiply first and second. When you multiply first and second, my dear friends, what will you say? Sir, you will say, sir, this R into V square. So this will be R into V square will be equals to. From the right side, from this side, N square divided by N square. So N square divided by N square. This and this, it will be 1. Okay. Now, can I say from here, V will be 1 divided by under root of R if you take this over here. Now, guys, what did you do actually by this mathematics? You converted velocity into radius. Now, this is the equation third. Call this as equation third. This is the equation third. Now, I want you to put this in the equation third. So, I can say put in equation third. So can I say this angular momentum will be, that is m, instead of this 1 by root r, okay, and this will be r over here. Now what I want you guys to do is multiply with root r and divide with root r, okay, root r. Now root r and root r will becomes r, that will cancel with this r. So L will be equals to m into root r. Now what is the relation? Now mass is constant. So I can say L is proportional to root r. So what is the relation? That is options. Is this question clear? Guys, directly you cannot say L is proportional to R. Okay, directly you cannot say L is proportional to R. Why? Because that is only possible when V is constant. Okay, if they mention V is constant, then you can say L is proportional to R, but they are not mentioning. So you have to convert V into R first. Then you have to check. Is this clear? Please tell me in the chats with the fire emojis. Is this clear? Please tell me in the chats with the fire emojis. Everyone means everyone. Is this clear, guys? Tell me with the fire emojis. Okay, let's take a look at this. Hydrogen atom in ground state is excited by a monochromatic radiation of lambda is equal to 975 angstrom. Okay. Hydrogen atom in ground state is excited by a monochromatic radiation of lambda is equal to 975 angstrom. See guys, it says that there is a hydrogen atom which is in the ground state. If I make the hydrogen atom over here, okay. So in this particular case, I am saying, let's suppose this is the ground state. Okay, this is the first orbit. Ground state means first orbit. So this is the second orbit. This is the third orbit. This is the third orbit. Okay. Yes. Now guys, if this is the nucleus. If an electron is revolving in the ground state, and if you give this to an energy of 975 angstrom, if you give this to an energy that is of wavelength 975, what will be the energy? Energy of a photon will be, it is angstrom. That is 12400 divided by 975. Okay. It will be, energy will be 12.4 electron. Around this only, 12 point something. Okay. Now guys, if you are giving this much of energy to an electron, could you please tell me what is the energy gap between first and fourth? That is exactly like this. So it will go to the fourth orbit. So it will move from n is equal to 1 to n is equal to 4. Why? Because if you give the energy to an electron, it goes to the higher orbits. So if you give this much of energy, means it will move from n is equal to 1 to n is equal to 4. Now it says number of spectral lines formed. We know that whenever electron makes the transition on the spectrum, okay, on the spectrum, we say lines are formed. That is what I have discussed previously. Now, if somebody says that, sir, how many number of lines are formed on the spectrum? How do you calculate those lines? We say number of spectral lines formed. Guys, it is N2 minus N1 into N2 minus N1 plus 1 divided by 2. This is the formula. This is the final orbit. This is the initial orbit. Okay. Now tell me, in this particular case, this will be 4 minus 1 into 4 minus 1 plus 1 divided by 2. This is how we calculate the number of spectral lines in this particular case, and it will come out to be 6. It will come out to be 6. Okay. It will come out to be 6. It will come out to be 6. Okay, what is the formula? We say if an electron makes the transition, we say spectral lines are formed on the spectrum. How many number of lines will be formed? That is N2 minus N1 upon into N2 minus N1 plus 1. So here N2 is 4, N1 is 1. And this formula you can use, you can find the number of spectral lines. Okay, this is the question from JEE Mains 2021. JEE Mains 2021. JEE Mains 2021. Now guys see. Okay. Now you will remember the formula from now onwards. Huh? D. Kumar. Now guys, in Bohr's atomic model, let K, P and E are the kinetic energy, potential energy and total energy of an electron respectively. Choose the correct option if an electron goes to the higher orbit. Guys. If I say this is the nucleus, around the nucleus, this is the first orbit, this is the second orbit, this is the third orbit. Let's suppose if I'm saying an electron makes the transition from lower orbit to the higher orbit. This is the radius of lower orbit, this is the radius of higher orbit. Can I say in this particular case radius is increasing? Here R increases. Can I say in this particular case R increases? If an electron makes the transition from lower orbit to the higher orbit, we say R increases, radius increases. Yes. Now, my dear friends, listen to me very carefully. We say, sir, what is the energy of an electron, kinetic energy of an electron in the nth orbit? We know, sir, kinetic energy is, that is Z E square upon 8 pi epsilon naught R. Sir, when it comes to the potential energy is minus Z E square upon 4 pi epsilon naught R. This is the potential energy of an electron in the nth orbit. What is the total energy? Total energy is minus Z E square upon 8 pi epsilon naught R. Okay. This is total, this is potential, this is kinetic. Now, first and the foremost thing, you tell me one thing. Kinetic energy is inversely proportional to R and kinetic energy is positive. If I say if R increases, okay, what will happen to kinetic energy? We say kinetic energy decreases. Simple, kinetic energy decreases. Simple, why? Because it is inversely proportional. Now, let's take a look over here. Sir, if R increases, we say if R increases, tell me guys, if R increases means if an electron moves to higher orbit, what will happen to potential energy? Potential energy will decrease. Please wait a second. Potential energy decreases. But in negative value, potential energy decreases in negative value. Okay. Now, if something is decreasing in negative, means overall it is increasing. A minus 5, minus 10. Minus 5, minus 10. If you decrease something, okay, if we say here, potential energy is decreasing in negative value, means overall it is increasing. So, overall, it increases. I hope this point is clear. Same logic for total energy. Same. Why? Because it is negative. So we say if R increases, okay, I say total energy decreases in negative value. Okay. And if total energy decreases in negative value, okay, means overall it is increasing. Overall, it increases. So can I say in this particular case, which option? Kinetic energy decrease, potential and kinetic increases. Option B. What about this one? This is also the question from JEE Mains 2021. Tell me, what does the question say? A proton, neutron, and electron and alpha particle have the same energy. Their de Broglie's wavelength compares as, you are supposed to say which option is the correct option. Guys, see, when it comes to the alpha particle, okay, when it comes to the proton, when it comes to the neutron, okay, when it comes to the proton, when it comes to the electron, guys, always remember, mass of alpha particle is greater than mass of neutron, is greater than mass of, or some people say mass of neutron is equal to mass of proton, is greater than mass of electron. This one. Now, when it comes to their de Broglie's wavelength, guys, can I say, and I have the same energy. Okay, de Broglie's wavelength is h upon under root of 2m into kinetic energy. Now, guys, see, Planck's constant is same for all the four particles. Kinetic energy is same for all the four particles because it is saying, so lambda is inversely proportional to mass. So means the one which has got more mass will have less de Broglie's wavelength. Okay. Now I can say here lambda for alpha particle will be less than lambda for neutron, will be equals to lambda of proton, will be less than lambda of electron. So option B. Take a look at this. This is also the question from JEE Mains 2022. This is the question from JEE Mains 2022. An electron moving with the speed v and a photon moving with the speed c. Electron and photon have the same de Broglie's wavelength. So means an electron and a photon, they have got the same de Broglie's wavelength. The ratio of kinetic energy of electron and to that of photon. Okay, see. How can we write this? Sir, it is h upon, how do we write it? h divided by mv. Because the general formula is h divided by p in terms of momentum. P means mv. This is the de Broglie's wavelength in terms of momentum is equal to, and when it comes to an photon, guys, we say energy of photon is hc divided by lambda. From here, lambda is going to be hc divided by E. So I can write over here, this is going to be hc divided by energy of photon. Now, guys, tell me one thing. Can I say, we say as. When it comes to the kinetic energy of an electron, we can write it 1 by 2 mv square. Yes. Now multiply this over here. This will be 2 times of kinetic energy divided by v. What remains over here? M into v. Now do one thing. Put this mv over here. Put in equation first. I want you to put this in equation first. When you put this in equation first, you will write over here h divided by, instead of mv, you will write 2 times of kinetic energy, and kinetic energy of an electron you will write EE or KE, one and the same thing. Okay, divided by v will go in the numerator, will be equals to hc divided by energy of photon. H and H will cancel. We are supposed to find energy of electron to that of photon. Take this over here and take this over here. So this will be v divided by 2c is equal to energy of electron divided by energy of photon. Which option do you think is matching? V divided by 2c, option C. See, we are supposed to find the ratio of kinetic energy of electron to that of photon. That's why I took it over here. Yes, I'll be sending this particular PDF after the session. Chill. And guys, if you have not joined my Telegram channel yet, I would want you guys to join it. It is t.me/YAWARMANZOOR. Okay, this is where I send all the notifications, all the notes, everything. Do join this particular Telegram channel. t.me/YAWARMANZOOR. Okay, what about this? What about this? This is the question from spectral lines. I have already shown you a lot of questions from the spectral lines when we were discussing the top 50 concepts. Okay, over there we have discussed. Now guys, take a look. The ratio of wavelength of the last line of Balmer series, the ratio of wavelength of the last line of the Balmer series and the last line of the Lyman series See guys, when it comes to the Balmer series, guys, what is the final orbit in case of Balmer series? We say, sir, n final in this particular case is 2. What is the initial orbit? N initial in this particular case is infinity. Why? Because you are talking about the last line. Last line means when an electron makes the transition from infinity to the second orbit. First line means when an electron makes the transition from third orbit to the second orbit. Last line means from infinity to second. And how do you find the de Broglie wavelength, okay, of that particular photon? I would say 1 divided by lambda is equal to R. Then we say 1 by n final square minus 1 by n initial square. This is the formula by which if an electron makes a transition from higher orbit to lower orbit, photon is released. So the wavelength of that photon is this. Okay. This 1 by lambda is wave number. Lambda is wavelength. So 1 by lambda Balmer, I'll be writing R, and this 1 by n final square, 1 by 2 square is 1 by 4 minus 1 by infinity, that is 0. Now this will come out to be lambda B. Lambda B will come out to be, that is 4 divided by R. Because 1 by lambda is equal to R by 4. If you do the reciprocal, this will be 4 by R. Now, if I say in case of Lyman series, guys, if an electron makes the transition from higher orbit to the first orbit, that is called Lyman series. R is Rydberg constant, yeah. So we say in this particular case, n final orbit is 1. Now, if we are talking about the last line, so means n initial will be infinity. So for last line, initial will be infinity. Now guys, if you have to write over here 1 divided by lambda Lyman, it will be R. Then 1 by n final square minus 1 by n initial square. Okay, yes. Now tell me, guys, 1 by lambda Lyman is, it will be R, and then 1 by n final, that is 1 by 1 square minus 1 by infinity, so it will be 1 by 1 only. So lambda Lyman will be 1 divided by R. Now you have to find lambda Balmer divided by lambda Lyman. So lambda Balmer divided by lambda Lyman, it will be, guys, it will be, that is 4 divided by R upon 1 divided by R. This and this will cancel, so it will be 4:1. So ratio is 4:1. So option B. Okay, what about this one? The binding energy per nucleon in deuterium. Okay. When the two, what is the energy released? You are supposed to find the Q value of the reaction. Guys, see. Take a look. The binding energy per nucleon in deuterium and helium are 1.1 MeV and 7.0 MeV. See guys, when two deuterium nuclei fuse to form a helium nucleus, the energy released would be, see guys, it says that when two deuterium nuclei fuse, deuterium means 1H2. So 1H2 plus 1H2. Let's first write the equation, reaction. So when two deuterium nuclei fuse, okay. When two deuterium nuclei fuse, we say to form a helium nuclei, helium means alpha particle, 2He4, and some energy is released, that is Q. You are supposed to find in this reaction, so basically this is a nuclear reaction in which two deuterium nuclei are fusing to form helium, and in this process some energy is released. You have to find the Q value of the reaction. Let me show you. When it comes to the Q value of the reaction, I have told you the formula many times. Guys, Q value of the reaction means binding energy of products minus binding energy of reactants. What is product over here? Product means this. What is reactant over here? Reactant means this. Now, how do you calculate the binding energy of products? I'll show you. Sir, Q is equal to. Now, see, when it comes to the binding energy of products, guys, see, how many nuclei, this 4, what does 4 mean? 4 means this is a nucleus. How many number of nucleons are inside the nucleus? 4. Nucleons means protons plus neutrons. 4. Now see, the binding energy per nucleon. Binding energy of one nucleon. Per nucleon means one nucleon. The binding energy of per nucleon in deuterium is 1.1. And binding energy per nucleon of helium is 7.0. Means one nucleon of helium has binding energy 7.0. How many are there? 4. So 4 will have how much? 4 into 7.0. Simple. If it is saying binding energy per nucleon, binding energy of one nucleon, so multiply it with the number of nucleons, you'll get the total binding energy. Then we say minus. Binding energy of reactants. Guys, in reactants, how many nucleons are there? 2 plus 2 is 4. So we say 4 into binding energy of one nucleon is 1.1. 1.1. I hope this is clear. Now, this is 28 minus 4.1. Okay, it will be 23.6. Okay, this is the option. This is the correct option. Is that clear? 23.6. Is that clear? Is that clear? This is how we find the Q value of the reaction. Okay, what about this question? A nuclear ruptures into two nuclear parts. A nuclear ruptures into two nuclear parts. It says that there is a nucleus. It breaks into two nuclear parts. It basically explodes into two nuclear parts. Okay. So this is the first part. This is the second part. A nucleus breaks into two nuclear parts. Okay. First part and second part. Okay. Nuclear ruptures into two nuclear parts which have their velocity ratio. Now guys, see. Let's suppose this is mass M. This is mass M1. This is mass M2. It breaks into two nuclear parts. Now, this goes here with a velocity V2. This goes here with a velocity V1. Okay. So, why will they go here? Because they have to conserve the momentum. They will move opposite. Now, it says that velocity ratio V1 divided by V2 is given as 2 divided by 1. You guys are supposed to, what is the ratio of their nuclear size? Nuclear size means you are supposed to find the value of R1 divided by R2. Ratio of their radii. Okay. Now guys, can you tell me what is the common concept that we use in this particular case? What is the one single thing that we use in this particular case? We say here, momentum is conserved. Here momentum is conserved. What does that mean? That means initial momentum is equal to final momentum. That means momentum of this will be equal to the momentum of this. That will be M1 V1 will be equals to M2 V2. Something like this. Yes. Now guys, take a look. Can I write over here this V1, or I can write over here this M1 divided by M2. If you take it over here, this will be V2 divided by V1. Yes. Now V1 by V2 is 2 by 1. V2 by V1 will be 1 by 2. So this is 1 divided by 2. Yes. So ratio of mass M1 by M2 came out to be 1 by 2. Now how do you write the mass of this? Sir, we say density is equal to mass by volume. We say density is equal to mass by volume. Mass will be equals to density into volume. Now when you write this, it will be density and volume. Volume of this will be 4 by 3 pi, and then we say pi r1 cube, then whole divided by a rho 4 by 3 pi radius of the second one is r2 cube will be equals to, this is mass m1 by m2, this will be equals to 1 divided by 2. Now 4 by 3 pi, 4 by 3 pi. So can I write in this particular case r1 by r2 whole cube? So r1 divided by r2. If you take this cube over here, it will become 1 upon 2 whole raised power 1 by 3 cube root. Okay, so which option is correct? 1 r1 divided, okay, this one. Option B. Okay, this one. Tell me the answer of this question. M and N MP represents the mass of neutron and mass of proton respectively. An element of mass M. Okay. Let's suppose you have got an element or a nucleus. It has got mass capital M. Okay, it has got mass capital M. Okay. Has n number of neutrons. If it has got n number of neutrons and z number of protons, then the correct relation would be, guys, see. Let's suppose you have got a mass M. This is a nucleus. Now guys, if you break the nucleus, okay, you break. So while you break the nucleus, you have to use energy. You use energy in breaking the nucleus. Now guys, how many number of nucleons are inside? It has got n neutrons. It has got z protons. N neutrons and z protons. And what is the collective mass of this? That is M. If you break this nucleus, we say you take these nucleons out. How many number of nucleons? You say, sir, n number of nucleons. Guys, tell me one thing. N number of neutrons, z protons. I'm saying that what will be the mass of n neutrons? It says that an element having mass M and okay, Mn is the mass of neutrons, Mp is the mass of protons. How many neutrons, sir? N. If you have one neutron, so what is the mass of one neutron? 1 into Mn. If you have two neutrons, what is the mass of two neutrons? 2 Mn. If you have three neutrons, what is the mass of three neutrons? 3 Mn. So I can say in this particular case, when you take it out, so how many neutrons? We say n neutrons, and mass of n neutrons will be, that is Mn into n. Okay, then plus. If you take z protons out, what is the mass of z protons? Z into Mp. Now guys, listen to me very carefully. When you take these nucleons out, number of neutrons, number of protons, we observed that its mass came out to be greater than collective mass. Guys, what is the mass inside? Let's suppose they have got 10 kg. 10 plus 10 is 20. When you take these out, how much should come out to be? 10 plus 10, 20. But it came out to be greater than collective mass. Why? Because you are using the energy in breaking the nucleus. That energy is stored in the form of mass. That's why this has been observed. This is called mass defect. This concept is what we call mass defect. And this is a previous year question. So which relation is correct? Individual mass is greater than collective mass, means collective mass is less than individual mass. So option A is correct. This concept is called mass defect. Is this clear? Why is this individual mass came out to be greater than collective mass? Because the energy which you are using in breaking the nucleus is stored in the form of mass. Okay. Now guys, smash the like button if you have not liked the session yet. Let's move on to the semiconductor portion. Guys, see, You have got over here this question. You need to simplify this. Guys, in order to simplify this, we use De Morgan's law. You have a complete bar. In order to, what does De Morgan's law say? In order to break this bar, you can break it. You can write it A bar dot B, whole bar. And this addition sign needs to be changed in multiplication. That's what De Morgan's law say. B bar dot A whole bar. What does De Morgan's law say? If you want to break the bar, this addition sign needs to be changed to multiplication. And if it is multiplication here, it will change to addition. That's it. Now further, I want you guys to break this bar. Here it is A bar and here break this bar. So this multiplication sign will change to addition. So it will be B bar. Then here also break this whole bar. So it will be B double bar. Okay, then we say this multiplication sign will change to addition, something like this. Now always remember, whenever you have two bars cancel each other. I have told you this. A bar will cancel, so it will be A plus B bar multiplied by, you have B double bar, it will be B only plus A bar. Okay. Now guys, tell me one thing. Multiply this A with B. So this will be AB. Okay. Multiply this A with A plus A bar. Okay. Then we say plus, multiply this B with this. This is B bar into B. Then multiply this with this. So this will be plus B bar A bar. Now guys, this also I have told you, if you have A into A bar, this will be 0. This will be also 0. So you can write directly over here AB plus A bar B bar. This is the final result. This is the final result. Is this clear? Simply I am using the De Morgan's law over here. That's it. That's it. That's it. Let's talk about some assertion reason. All of these assertion reason were asked in, we say all of these assertion reason were asked in, we say NEET aims, previous year aims. Now guys, take a look. When it comes to this particular question, if the temperature of a semiconductor is increased, okay, the resistance decreases. Now tell me guys, if the temperature of a semiconductor is increased, the resistance decreases. Is this correct or incorrect? If you remember, when it comes to the resistance, guys, if this is a semiconductor, I have told you previously, semiconductor has got, this is the conduction band, this is the valence band. Okay. Now guys, valence band is completely filled with the electrons and conduction band is completely empty. This is conduction band, this is valence band. Now if you increase the temperature, we say these electrons vibrate and they will shift to the conduction band. And now they become free electrons. And we know free electrons create the electric current. Okay. So if free electrons are present in here, we say conductivity will increase and resistivity will decrease. So it is correct. If the temperature of a semiconductor is increased, its resistance decreases. It is correct. Let's talk about reason. The energy gap between the conduction band and the valence band in case of a semiconductor is small. Yes. If we talk about the energy gap, this gap between the conduction band and valence band, this is small. That is the reason electrons are able to shift to the conduction band. In case of insulators, this gap is very large. The electrons are not able to reach. We say conduction band. So here in this particular case, we say yes, assertion is correct, reason is correct, and reason is the correct explanation of assertion. Okay. Now guys, take a look. I'll complete that series also. Chill, take a chill pill. Don't worry about that. TJR Nandu. Okay. No tension. Assertion. Conductivity of a semiconductor increases on doping. Doping means adding the impurity. When you add impurity, guys, I have told you in case of semiconductors, when you add impurity to a semiconductor, we say its conductivity increases. Why do we add impurity? So that conductivity increases. Yes, correct, correct. Okay. Doping raises the temperature. How does impurity raise the temperature of a semiconductor? Wrong. So assertion is correct, reason is false. Option C. Okay, what about this? For a given applied voltage, conduction current in N-type semiconductor is more than that in P-type semiconductor. Yes, when it comes to the N-type semiconductor, guys, for N-type, could you please tell me what is the majority charge carriers? Electrons. Yes, sir, electrons are the majority charge carriers. And when it comes to the P-type, what is the majority charge carriers? Holes. Okay. Now tell me guys, we say mass of electron is much less than mass of hole. Okay. Now, if there is, I have told you this many times, if there is a fat person and there is a lean person, which one is free to move? Fat or lean? Lean, obviously. Why? Because its mass is less. So we say mobility of electron is greater than mobility of holes. Why? Because we say mass of electron is much less than mass of holes. That's why mobility is more. So now reason says mobility of electrons is greater than the mobility of holes. Assertion is correct, reason is correct. So option A. Let's talk about this one. The temperature coefficient of a resistance is positive for metals and negative for semiconductors. Temperature coefficient means, guys, in current electricity, I have told you this. R resistance at temperature T is equal to R naught resistance at 0 Kelvin 1 plus alpha delta T. This alpha is what we call the temperature coefficient of resistance. This alpha basically tells you if in a material, if you increase the temperature, what will happen to the resistance? Alpha tells you if in a material, if you increase the temperature, what is going to happen with the resistance? And when it comes to the conductors, guys, see, we say in case of conductors, alpha is positive. Why? Because when you have a conductor, if you increase the temperature, we say vibrations increase. If vibrations increase, we say resistance increases. Yes. Now, my dear friends, that is only possible if you keep alpha positive. Why? Because if you keep alpha negative here, final resistance will be R naught minus something. So final resistance will decrease. If you keep alpha positive here, R naught plus something, final resistance will increase, resistance at temperature T. So for conductors, alpha is positive. For semiconductors, alpha is negative. Why? Because on increasing the temperature in semiconductors, resistance decreases. Why? Because electrons shift from valence band to conduction band. That's why. So assertion is correct. On raising the temperature in metals, drift velocity decreases, but in semiconductor, more charge carriers are released. That's what I was saying. Okay, so drift velocity decreases, but in semiconductors, more charge carriers are released. In semiconductors, if more charge carriers are released, we say resistance will decrease, conductivity will increase. This is okay. Now, which of the following statement is false? Pure Si doped with trivalent impurities gives a P-type semiconductor. When it comes to the P-type semiconductor, guys, we say you take a pure silicon or pure germanium. Okay, pure silicon or pure germanium. And in pure silicon, you add what impurity? That is trivalent impurity. Okay. And due to the trivalent impurity, only holes are created. So we say this statement is correct. We are supposed to find which of the statement is false. Okay, this is correct. So this is not our option. But in reality, this statement is correct. According to the question, this is false. Majority charge carriers in N-type semiconductor are holes. No. So means this is our option. In case of n-type semiconductor, majority charge carriers are electrons. That is what we have discussed. Majority in n-type are electrons, but it is saying holes. So we are supposed to find out the which incorrect statement. Majority carriers in a p-type semiconductor are electrons. Minority charge carriers in a p-type semiconductor are electrons. Correct. But according to the option, it is incorrect. So when it comes to p-type semiconductor, we say majority is holes and minority is electrons. Majority is holes and minority is electrons. The resistance of an intrinsic semiconductor decreases. Intrinsic semiconductor means pure semiconductor. Decreases with the increase in temperature. When you increase the temperature, conductivity increases, resistance decreases. This is also correct. So we are supposed to find out the incorrect. That is option B. Okay. For forward biasing, positive terminal of the external battery is connected to the p-type. Yes, when it comes to the semiconductor, okay, forward bias. Let's suppose I'll make a p-type semiconductor over here. This is p-type semiconductor. If you do forward biasing, this is positive terminal, this is negative terminal, this is positive and this is negative. So it is connected to positive terminal, it is connected to negative terminal. This is called forward bias. And when it comes to the reverse bias is this. Positive is connected to N side, negative is connected to P side. Okay, this is P side. Back side means P side. This is the symbol. So for forward biasing, positive terminal of the external battery is connected to P side and negative terminal of the external battery is connected to N side. Correct? This would support the tendency of the majority charge carriers to cross the junction. Yes. If I make it over here, see. If I make it over here, this is P type, this is N type, and this is the battery. This is in forward bias. This is positive, this is negative. In P type, majority charge carriers are holes. Holes have got positive charge. These are, here it is electrons. Majority charge carriers are electrons. Now, when you connect positive charge from this side, it will send positive charge over here. Now, this positive charge will repel the positive charge of holes. This negative charge will repel the electrons. We say this is called depletion region. Depletion region decreases. When depletion region decreases, we say these electrons will come and it will shift to the holes. Electron hole recombination takes place. This would support the tendency of majority charge carriers, means electrons, to cross the junction. Majority charge carriers will cross the junction. So I would say in this case, option A is the correct option. Option A is the correct. Assertion is correct. Reason is correct. Reason is the correct explanation of assertion. Is this correct? Is this correct? Okay. This is a previous year question, NEET 2020. And this is the AIMS question. This was asked in the AIMS. What about this one? Which of the following is the forward bias? I have told you forward bias means this is the PN junction diode. This is P side and this is N side. Okay, this is P side and this is N side. Now, when it comes to the forward bias, When it comes to the forward bias, we say this is higher potential, this is higher potential, this is higher potential. Okay, 3 volt. Sorry. This is higher potential, 5 volt. This is lower potential. So N side is connected to higher potential and P side is connected to lower potential. So means this is forward bias. Whenever P side is connected to higher potential, N side is connected to lower potential, it is forward bias. Okay. What about this one? This is P side and this is N side. Here, P side is connected to 0, it is -2. So here this is higher potential, this is lower potential. Okay. This is also forward bias. Okay. And what about this one? Here, this is -4, lower potential, and this is -3, higher potential. Your N side is connected to higher potential. This is reverse bias. What about this one? What about this one? Here, -2 is connected with this. This is reverse bias. Because this is connected to higher is connected to N side. Here, this is N. N is connected to higher. This is also reverse bias. This is also reverse bias. Which of the following is in the forward bias? Only second one. Second is the correct option. Okay. Let's talk about this particular question. Guys, see. The current flowing through the battery will be, or the current flowing through the resistance will be. See, guys, you have got a diode over here. Diode means this is what we call the barrier potential. This diode, this is what we call the barrier potential. Like if I make the graph between current versus I versus V. In case of a diode, guys, see, in case of a PN junction diode, if I make the graph between I versus V, everybody knows that, sir, in case of forward bias, graph of a semiconductor is something like this, I versus V. Now, what is this? Here, current is very large. So this is what we call the barrier potential. Barrier potential. So we say when barrier potential is achieved, then current in the diode will become large. Okay. At that point of time, it will behave like a simple wire. Now see, what is the barrier potential of this? I would say this is 0.7 volts. What is the barrier potential of this? 0.3 volts. Means current will flow in this diode when how much potential difference is achieved? 0.3 in this 0.7. Now 5 volt is given. So in 5 volt, from this 5 volt, 0.7 will take this diode, 0.3 will take this, 0.7 plus 0.3, that is 1. So how much is remaining? That is 4. So 4 volts will go in the resistor. Now if I say current in the resistance, that is V divided by R. So current in the resistance, V is given as how much? That is 4. Okay. And what is R? R is 10. 4 divided by 10 ampere is the current. 4 by 10 ampere is the current. Okay. Guys, what about this one? What about this one? You have got a diode. See. In this particular case, this is N side, this is P side. This is P side, this is N side. So N side of the semiconductor is connected to higher potential. P side of the semiconductor is connected to lower potential. In this particular case, this is reverse biased. Whenever a diode is reverse biased, always remember, it behaves like an open wire. No current flows through the diode. So reverse bias diode behaves like an open wire. Reverse bias diode behaves like an open wire. Okay. And when it comes to the forward bias diode, it will behave like a simple wire. Now, this is reverse bias. So remove it. No current will flow through this one. So current in this one will be 0. Current in this one will be 0. Now, how much? Only one diode is remaining. Potential difference in this will be 0.3. Now, 5 volt. Among this 5 volt, 0.3 will go in the diode. How much is remaining? 5 minus 0.3 is 4.7. 4.7 volts will go in the resistance. Now, let's find the current. Current in this particular case is V divided by R. V is 4.7 divided by 10. Okay. Tell me the answer of this one. Don't say in this particular case, this is reverse bias. Both are forward bias. Both are forward bias. What is going to be the value of current in this particular case? Tell me. What is going to be the value of current in this particular case? Tell me quickly. What is going to be the value of current in this particular case? See, guys. I have told you, what is this 0.5, 0.3? This is barrier potential. See, if I make for diode 1, if I make the I versus R graph, that is this. For diode 2, I versus R graph would be this. It will achieve the barrier potential. It will get the barrier potential at 0.5 volts. Okay. So means when 0.5 volt current will flow, sorry, 0.5 volt potential difference will be there across it, then we say current through this will be flowing by a large amount. But when it comes to the second diode, we say when only 0.3 volt voltage is achieved, we say current will be large. So means when this battery gives 0.1 volt, 0.2 volt, 0.3 volt, this diode is activated. When this diode is activated, all of the current will flow through this diode. So no current flows through this. Why? Because this gets activated at 0.3 volt only. Now tell me, 0.3 volt go in this one. 5 minus 0.3, how much will go in this one? 4.7. In this case also current will be 4.7 divided by 10. Is this clear? Is this clear? Please tell me in the chats, everybody out there. Is this clear? Now take a look, guys, in this particular case. Okay, this is the question from, this was the question asked in JEE mains. JEE mains 2022. This was the question asked in JEE mains 2022. Okay. This was the question asked JEE mains 22. Now, in this particular case, we are given over here the Zener diode. This is the question on Zener diode. What is the work of a Zener diode? It says Zener diode is that diode which maintains the potential difference. Like. Let's suppose, my dear friends, listen to me very carefully. Let's suppose you have got a resistance over here. Okay, this is a battery. Okay, this is 100 volt battery. So 100 volt battery. How much voltage it will give to the resistance? All of 100 volt will go in this one. Now I'm saying potential difference voltage of 20 volts should be maintained across this. What will I do? Sir, you connect a Zener diode to it. Which should have the Zener voltage of 20 volts. Okay, in the market, there are different Zener diodes available. 20 volt, 30 volt, 40 volt. It depends which one do you need. If I need a Zener, if I need to maintain 20 volts across it, I'll connect a Zener diode of 20 volts Zener voltage parallel to it. Now, it will maintain. Now, whatever is the potential difference across this, same will be across this. No matter, it doesn't matter how much amount of potential difference you are sending through the battery, from the battery. It will maintain between these 2 points, it will maintain 20 volts. So means 20 volts will be across this. Okay, yes. Now take a look here. Guys, and. In this particular case, listen. If you take a look at this particular diagram over here, okay, I hope this is visible. I hope this is visible. Let me make it over here. Let me make it over here, this diagram. Okay. This is the output voltage. This is the output voltage. And this is the input voltage, V input. You are supposed to plot the graph of V output. See guys, this has the Zener voltage of 6 volts. This has the Zener voltage of 4 volts. And this is 100 ohm resistance connected here. This is the load resistance. Now see, guys, means if you give, let me show you. Let me make the graph. Let me make the graph. Output. This is the graph of output. This is the graph of output, VO. Guys, let's suppose if V input I am giving, let's suppose 1 volt. I am giving potential difference of 1 volt to this particular circuit. Now, this has got the Zener diode of Zener voltage 6. So means it will remain off. Diode remains off until it achieves Zener voltage. Before that, it remains off. So it remains, it will not work. It will not work. We say, sir, what about this diode? This also remains off. So if you are giving 1 volt, we say 1 volt will go in this load. It will achieve 1 volt. So we say V output in this particular case is 1 volt. If I say V input in this particular case is 2 volts, okay? If you are giving 2 volts, this diode remains off, this remains off, so 2 volts will be the output voltage. So till here, graph is a straight line. Graph is a straight line. If I am giving, let's suppose, sir, 3 volts, V input is 3 volts. This also remains off, this also remains off. So output in this case will be 3 volts. So still it will keep on going. Okay. Let's suppose I am giving V input is equal to 4 volts. Okay. What about output voltage? Guys, now listen to me very carefully. We say now this diode is activated. If this diode is activated, it will maintain across it. It will maintain across it 4 volts. And here also across this 4 volts will be maintained. Okay. So we say output will be 4 volts. So it will keep on going. It will keep on going. Okay. It will keep on going. Okay. Okay. Yes. Now, my dear friends, let's suppose if you are giving input voltage as 5 volts, what is going to be the output voltage? Guys, this remains off because its Zener voltage is 6. This is activated, okay? So we say it will maintain across it how much? How much? We say 5 only. Sorry, 4 only. No, doesn't matter how much amount of extra you give. It will maintain 4 only. So how much is the rest? 1. That 1 volt will go in this 1 volt. So 4 plus 1 is 5. So across this point and this point will be 5 volts. Across load also it will be 5 volts. Similarly, my dear friends, when you give V input as 6 volts, now this diode is activated. So this diode will maintain 6 across this. So this is parallel across this also 6, across this also 6. So V output in this particular case is 6. So it will go till 6. Now, if you give V input as 7 volts, this will maintain only 6. Okay, across it. So across this also 6, across this also 6. So V output will be 6 only. So when you give 7, it will be 6. So after 6, so this will be 6 volts. So it will remain constant. It will remain constant. So which option is the correct option? Option D. I hope this is clear. So basically there is one concept in Zener diode, that is until and unless the diode achieves the Zener voltage, it remains off. Okay. Before that, okay, like 5 volts, 4 volts, diode remains off. When you give the 7 volts, 6 volts to it, it will activate. If you give more than 6, it will maintain 6 only. That's the working of a Zener diode. That's the working of a Zener diode. Okay, tell me, this is the question, one more question. This is one more question on Zener diode. Find the current in Zener diode. Guys, see. What is the value of V Zener? 15 volts. If it has 15 volts, means it will maintain 15 volts across it. This is connected parallel to this. Across this also it will be 15 volts. Now let's suppose, guys, 20 volts. So out of 20, how much is the potential difference across this? 15. Okay. And how much is remaining? 15 plus 5 is 20. So across this, it is going to be 20 volts. It is going to be 20 volts. Okay. It is going to be 20 volts. Oh, sorry. It is going to be 5 volts. 5 volts. Okay. Because 5 plus 15 is 20. Now, guys, tell me. What about this one? How much is the current in this one? If I say this is the current I, you'll say, sir, current is V divided by R. V is 5 divided by 100. Okay. V by R. Now, this current I is divided over here in this one. This will be I Zener. And in this one, it will be I load. Now, in this load, you'll be saying, sir, I load current in this particular case will be how much? V by R. V is 15. R is 500. So, 5 3s are, 5 1s are. So this will be 3 divided by 100. Okay, 3 by 100. This is 5 by 100. Now guys, we said this current I is divided into IZ and IL. So can I say current I is equal to IZ plus IL? Yes. Now here, I can say, what is the value of IZ? IZ will be I minus IL. So this IZ will be, what is the value of I? That is 5 divided by 100 minus 3 divided by 100. It will come out to be 2 divided by 100. Okay, 2 divided by 100. Now take a look at this particular question. This is the question from alternating current. Smash the like button, guys, if you have not liked the session yet. Okay. Now guys, take a look. Equation of an alternating current is given as, this is the equation of alternating current, 10 root 2 sine of 100 pi t plus pi by 6. So alternating current equation is given as I is equal to 10 root 2. Then we say sine of 100 pi t plus pi by 6 plus pi by 6. Okay. Yes. This is the equation of alternating current. The time taken by the current to reach its root mean square value. Guys, see, root mean square value of the current is IRMS. How do we calculate that? That is peak value. This is the peak value. That is peak value divided by root 2. So that will be 10 root 2 divided by root 2. This will be the RMS value or root mean square value of the current. Now, guys, I can say, put this value over here, So I can write over here a 10 root 2 divided by root 2, because if you want to find out the current, if you want to find out the time in which it reached root mean square value, you have to put it here. So it will be equals to 10 root 2 sine of 100 pi t plus pi by 6. Now, guys, if I say find the time in which current reaches 50 ampere, you'll be putting the 50 here. Find the time in which current reaches 5 ampere, you'll be putting 5 here. Now see, guys, 10 root 2 will cancel. So it is 1 by root 2. When is the value of when is the value of sine as 1 by root 2? Sine 45, that is sine pi by 4. Sine of pi by 4 is 1 by root 2 is equal to sine of 100 pi t plus pi by 6. This is a J means previous year question. Now sine pi will cancel. So here it is 1 by 4 is equal to 100 t plus 1 by 6. Take it here. 1 by 4 minus 1 by 6 is equal to 100 t. Okay. Now guys, in this particular case, I want you to cross multiply. So this is 6 minus 4. 6 minus 4 divided by 6 minus 4 divided by 6 into 4 is 24. 24 is equal to 100 t. Now 6 minus 4 is 2. 2 by 24, that is 1 by 12 is equal to 100 t. So time will come out to be 1 by 1200 seconds. So after 1 by 1200 seconds, current will reach its root mean square value. Okay. Like if you check the graph of alternating current, it is like this, sinusoidal. Okay. Guys, this is called the peak value of the alternating current. Okay. This is I naught, peak value. Root mean square value will be somewhere around over here. Sir, how much time it will take? 1 by 1200 seconds. Okay. What about this one? This is also previous year question, means 2022. A resistance of 40 ohm is connected to an AC source of 220 volts, 50 hertz. 50 hertz means frequency. This is frequency. Okay, this is frequency. And this one is what we say RMS value. Okay. Now guys, take a look. The time taken by the current to change from its maximum value to RMS value. See guys, if we make the graph of a sinusoidal current, graph is something like this. Okay. Now guys see. This is what we call the peak value of the current. Okay. Yes. And my dear NEET aspirants, if I say in this particular case, sir, peak value would be somewhere around over here. This is the 0. This is peak. And somewhere around over here, this will be the RMS value. Okay. Now from IRMS, listen to me very carefully. From here to here. So from 0 to peak value, it takes the time t by 4. Always remember. Then from peak value to 0, again it takes the time t by 4. Okay, this time is also t by 4. So t by 4 plus t by 4, here time is t by 2. When further it goes maximum in the negative side, so here also this is t by 4. Now then again when it becomes 0, this is t by 4. This is what we call one cycle of an alternating current. T by 4 plus t by 4 plus t by 4 plus t by 4 means capital T, 1t. Like here time is 0, t by 4, t by 2. Here it will be 3t by 4 because t by 4 plus t by 4 plus t by 4 is 3t by 4. Then plus t by 4, it will be complete 1t. Okay. Now guys, it says that when current goes from RMS, then goes peak, then again it goes to RMS. Na? See. Here, yes. How much time is taken by the current to change from maximum value to RMS value? Okay. Now guys, see, it is like this. So here current is 0. Here current is I naught divided by root 2 means RMS. Here current is peak value, that is I naught. What is the time from here to here? What is this time? This is t by 4 from 0 to peak. Let's suppose this time is t1, this time is t2. We are supposed to find the value of t2. How much time it takes from RMS to peak or peak to RMS? That is t2 time. We are supposed to find the value of t2 time, this time. How much it takes from this to this. Okay? Yes. Now guys, take a look. We say as. When it comes to the general form, basic form of sinusoidal current, you say I is equal to I naught sine of omega t. I is equal to I naught sine of omega t. Okay. Now, let's calculate this T1. Means how much time it is going to take from, we say 0 to RMS. Okay. So I would write over here time T1. Now put it RMS over here. I naught divided by root 2, because that is the RMS value, will be equals to I naught sine of omega t1. Now tell me guys, I naught will cancel. 1 by root 2 means sine of pi by 4. Sine pi by 4 is equal to sine of omega t1. Sine will cancel. So this is pi divided by 4 is equal to omega. Omega means 2 pi divided by capital T. Value of omega we say 2 pi divided by capital T. Okay, then we say T1. Pi and pi will cancel. So T goes here. So T1 will come out to be T divided by 8. So means this current will take the time T divided by 8 from 0 to IRMS. From 0 to IRMS. Okay. Now guys, you know the value of T1. You know the value of 0 to I naught, that is T by 4. You can find T2. Now can I say in this particular case, T1 plus T2 will be equals to T divided by 4. Yes. Now what is the value of T1? T by 8. T divided by 8 plus T2 is equal to T by 4. Take it over here. T2 will come out to be T by 4 minus T by 8. T by 4 minus T by 8. So T2 will come out to be T by 4 minus T by 8. That will be T by 8 only. And always remember, when it comes to the time period is inverse of frequency. It is inverse of frequency. So I'll write, instead of this, I'll write over here 1 divided by f into 8. Frequency is given as 50. So T2 will come out to be 1 upon 8, 50 into 8, or 8 into 50. Okay. 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 So 1 by 400 seconds. Is this clear? Is this clear? Tell me guys. Is this clear? Everybody out there? Is this clear? Now guys, take a look. Okay, same question once again. I would give you this as a homework. In an alternating current represented by this, okay? Your time is in T seconds and I is in ampere. Calculate the peak and RMS value of the current. Peak value of the current is 5. RMS value of the current is 5 divided by root 2. Frequency of the current. This is omega is 300. We say omega is equal to 2 pi f. So 300 divided by 2 pi. Done. Average current. Okay. So this one. Okay. Okay. This I'll give you as homework. Do it from your end. Simple. Next. Okay, this one is important. This one is important. This one is important. This one is important. Now guys, tell me in this particular case. I1 is equal to 4 sine of omega t minus pi by 6. Okay. And when it comes to this one, I2 is equal to 4 cos of omega t minus pi by 3. What is the value of I1 plus I2? Or I would write it something like this. Find I net. Find I net. Find the value of I net. Find the value of I net. Guys, see. In this particular case, you'll have to draw its phasor diagram. When you have this, guys, Let's suppose you have got, in case of a phasor diagram, we mark it something like this. We make it something like this. Okay. This is, on this axis we write sine omega t. Okay. On this axis we write cos omega t. Okay. From this side we write minus cos omega t, and from this side we write minus sine omega t. Okay. Now, if it is saying 4 sine omega t minus pi by 6, guys, if it was only sine omega t, I would have made on this axis, but it is minus pi by 6. Minus pi by 6 means anti-clockwise. Minus pi by 6. Pi by 6 means 30 degrees. Okay. So I'll be writing it something like this. So sine 4 sine omega t means this one. This is going to be I1. And this angle over here is 30 degrees. Okay, pi by 6 means 30 degrees. Okay, it lags behind sine omega t by how much? Pi by 6, that is 30 degrees. And when it comes to I2, 4 cos omega t minus pi by 3. Guys, if it was only 4 cos omega t, I would have made this current on this axis, but it is minus pi by 3. So means we have to go in anti-clockwise direction. Anti-clockwise direction, pi by 3 means this is 60 degrees. So cos omega t minus 60 degrees. So if this is 60, this will be how much? This will be 30 degrees. Okay, this is I2. And what is the peak value of I1? That is 4. What is the peak value of I2? That is 4. See, peak value is 4, peak value is 4. Okay. Now guys, if you have two currents, now tell me, if you have two currents or two vectors, both are having the same magnitude. Okay, angle between them is 60 degrees. Okay, what is going to be the resultant in that particular case? Guys, tell me. If you have two vectors, 4, 4, resultant in that particular case will be 4 root 3. Okay, we say if you have two vectors, this is A, angle between these two is 90, resultant will be root 2 of A. But if you have angle that is 60, resultant will be here 4 root 3. Now, this is the net current. This is the net current, peak value of net current. How do you write the equation of net current? I'll write it like this. Equation of net current will be, it is along sine omega t. So first I'll write peak value 4 root 2. Then I say sine of omega t. Sir, plus minus something, nothing. Why? Because this net current is along this only. 4 root 2 sine of omega t. Even in terms of cos also you can write, or you can write it like this. I net is equal to 4 root 2 is the peak value. Then we say this is cos. So it is along sine. So it is cos omega t minus pi by 2. You can write it like this also. Cos of omega t minus pi divided by 2. You can write it this also. Okay, you can write it in terms of cos. You can write it in terms of sine also. Okay. What about this one? This is the question from transformers. Transformers. A 220 volt input is supplied to a transformer. The output circuit draws a current of 2 ampere at 440 volts. Okay. A 220 volt input is supplied to a transformer. You have got a transformer. We say input voltage in this particular case is given as 220 volts. The output circuit draws a current of 2 ampere. So I output circuit draws a current of 2 ampere at 4 volts. Okay, at 440 volts. Okay, so means voltage output in this particular case is given as 440 volts. If the efficiency of the transformer is 80%, efficiency means neta, it is given as 80%. Efficiency of the transformer is given as 80%. Okay. If the efficiency of the transformer is given as 80%, the current drawn by the primary winding, of the transformer is, means you have to find the current in the primary winding, IP. You have to find the current in the primary winding. Guys, always remember, when it comes to the neta, efficiency of a transformer, it is output power divided by input power. It is always equal to the output power divided by input power. Now you can write over here this power output, that is neta into power input. Okay. Now, power, what is the formula of power? V into I. So you can write output voltage multiplied by input current, V into I. Sorry. So output voltage multiplied by output current will be equals to the neta. We say V input, I input, something like this, something like this. Now, when it comes to the output voltage is given as 440. Okay. Output current is given as 2 ampere, will be equals to, it is 80 divided by 100. Okay, 80%. Input voltage is given as 220. Okay. Input current is given as, that is what we need to calculate, I primary. Now, 220 ones are, 220 twos are. 2 into 2 is 4. 4 ones are, 4 twos are 8, 4 zeros are. Now this 0 and 0 will go, 20 ones are 20, 2 ones are 2 fives are 10. So if you take it over here, I primary in this particular case will be 5 ampere. It will be 5 ampere. Is this clear? Please tell me. Marathon will be from third. Okay. So this is the value of primary current in this particular case. Let's talk about this one. A step-up transformer operates on a 230 volt line and supplies a load of 2 ampere. Okay. The ratio of primary to the secondary windings is 1:25. Number of turns in the primary to the number of turns in secondary is 1 divided by 25. It is given. The ratio of primary to the secondary windings, okay? Number of turns in the primary coil is to number of turns in the secondary coil. That is given as 1:25. That is given as 1:25. Okay. Determine the primary current. You guys are supposed to find out the value of primary current. You guys are supposed to find out the value of primary current. Now, guys, what I want you to understand in this particular case, that is, we say we are assuming the efficiency of the transformer in this particular case as 100%. So in case of 100% efficiency, we say power output will be equals to the power input. Okay. 100% means 100 by 100, that's 1. Now, how do you write this? Sir, this is V output into V in I output. Okay. It will be V input into I input. Now, guys, here you will be writing V output divided by V input will be equals to I input divided by I output. Call this as equation first. Now, when it comes to the another equation, that is output voltage in case of a transformer, we say that is equal V output divided by V input. It is also equal to number of turns in secondary upon number of turns in primary. This is the another equation. Okay. This is the first equation. Now, here V output by V input is I in by I out. Here V output by V input is NS by NP. So can I say from first and second? From first and second. Can I not write over here? Guys, this I input by I output. I input divided by I output. It is going to be NS divided by NP. And NP by NS is 1 by 25. So this is going to be 25:1. So ratio of input current. Okay. Now we are supposed to find the input current. Determine the primary current. Now this I input will come out to be divided by. What is the current output? Output current draws a supply of 2 ampere. This is 2 is equal to 25:1. So 2 into 25 is 50 ampere. So I input will come out to be 50 ampere. Is this clear? Is this clear? Is this clear? Tell me, guys, in the chats. Is this clear? Okay. What about this one? What about this one? The primary and secondary coils of a transformer has 50 and 1500 turns. Number of turns in the primary coil, that is 50. Number of turns in the secondary coil, it has 1500, respectively. If the magnetic flux linked with the primary coil is flux in the primary coil, that is given as phi naught plus 4t, where phi naught is constant. You guys are supposed to find out the voltage in the secondary coil. Guys, see. We are supposed to find output voltage of the transformer. Guys, if flux is given, you are supposed to find the voltage, primary voltage. Can I say V input? It is going to be d phi divided by dt. This is Faraday's law. If flux through a coil is changing, EMF will be induced. That EMF is this. Now, differentiation of this will be, for phi naught it is 0, for 4t it will be 4. So, input voltage is 4 volts. Now, what is the formula I am supposed to use? Guys, when it comes to the output voltage in case of a transformer, it is number of turns in secondary upon number of turns in primary multiplied by input voltage. So, voltage output in this case will be number of turns in secondary. That is 50. 1500. That is 1500. And this will be 50 into input voltage, that is 4. 0 and 0 will cancel. 5 ones are 5 threes are 5 zeros are 120 volts. It is 120 volts. Okay, output voltage in this case will be 120 volts. What about this question? In an alternating circuit, okay, this is an LCR circuit, by the way, okay, this is an LCR, series LCR. EMF is given as this is, frequency is variable. The current at frequency F is equal to 0 and F is equal to infinity. It says that when it comes to this circuit, if frequency is 0 and if frequency is infinity, what is going to be the current in the circuit? See, guys. See, guys, when it comes to the impedance of LCR circuit, this is XL minus XC whole square plus R square. This is the impedance of an LCR circuit. Now, I can say in this particular case, Z will be under root of XL. XL will be omega into L minus XC will be 1 upon omega into C. Okay, and its whole square plus we say R square. Impedance means net resistance of the circuit. If you have to find the current in the circuit, guys, you have to say I is equal to V divided by resistance. Resistance means Z. For LCR circuit, net resistance is Z. Let's find that. Now, what is XL? XL is the resistance of this inductor. What is XC? XC is the resistance of capacitor. Capacitive reactance, inductive reactance. R is the resistance of resistor. Now you can write it like this. Z is equal to under root of, this is 2 pi F into L, because omega is 2 pi F. Okay, 2 pi F. So it is under root of, we say 2 pi F into L. 2 pi F into L. Okay, then we say minus 1 upon 2 pi F into C. 2 pi F into C. Okay, its whole square. Then plus we say R square. It says when frequency is 0 and when frequency is infinity. Guys, tell me one thing. We say if frequency is 0, if you place this frequency 0, this term will become 0 and this term will become 0. 1 by 0 is infinity. So infinity square is infinity. Infinity square plus something is infinity. So means Z in that case will come out to be infinity. And if frequency is infinity, let's suppose here you put frequency is infinity, this term will become infinity. 1 by infinity is 0. Now this is infinity. Infinity square is infinity. Infinity square plus something is infinity. So Z will come out to be infinity. Now, when frequency is 0, Z is infinity. When frequency is infinity, Z is infinity in both the cases. So if Z is infinity, current will come out to be 0 in both the cases. Current will come out to be 0 in both the cases. Why? Because resistance is very large. Anything by infinity? 0. So we say 0 and 0. Is this clear? Please tell me in the chats. What about this one? See guys, this is also a previous year question. In a series LCR circuit, the RMS voltage across the resistance and the inductor are respectively 400 and 700. So VRMS is given as 400. So, and VRMS across the resistor. Okay. And then VRMS across inductor, it is given as 700. Okay. Then it says, this is the applied voltage. This is the applied voltage. Okay. Then the peak voltage across the capacitor is V0 across capacitor. We guys are supposed to find out. Guys, first and the foremost thing, let's draw the phasor diagram. Let's draw the phasor diagram or impedance diagram or phasor diagram of this LCR circuit. See, VRMS is given for a resistor. When it comes to the voltage in case of resistor, let's make it something like this. This is the voltage in case of resistor. Okay. And this is the voltage in case of an inductor, because when it comes to the LCR circuit, we know when it comes to the LCR circuit, this is the resistance, we make it something like this. Okay, this is the voltage across resistance, voltage across inductance. Okay, this will be voltage across capacitance. Okay, this is VR and this is VL and this is VC. If you have studied LCR with me, I have told you over there, voltage across resistance, we make it something like this, across capacitor, across inductor. Yes, yes. Now guys, net voltage is given as 500 root 2. And when I say this 500 root 2, this is the peak value. This is the peak value. From this, if you have to find the RMS, we say RMS, ERMS for net. So it will be E naught divided by root 2. So that will be 500 root 2 divided by root 2. Root 2 cancel. That will come out to be 500. So 500 volt is the RMS voltage of the entire circuit. Okay. And in this particular case, my dear friends, I'll make it something like this is the net voltage. And net voltage, it has got the value of 500. Okay. This VR has got the value of how much? 400. This has got the value of 700. Now tell me guys, in this particular case, is it possible that if this is 400 in the forward direction, 700 in the upward direction, what is the resultant of, we say 700 and 400? Sir, obviously that is not 500. So 500 resultant is only possible if from this side it is 400. Now see, this minus this, 700 minus 400, it will be 300. Okay, resultant of this and this, 7 minus 4 is 300. Now that 300 and 400 will have the resultant of 500. So means it is not possible, sir. If you say from the lower side it is 0, if it is 0, then it is not possible. The resultant of 400 and 700 is 500. So something has to be from the lower side, and that is how much? That is 400. So I can say VRMS across capacitor, it is 400. And it is RMS voltage. If you have to find the peak from RMS, multiply it with RMS. Now we can say V0, that is peak across capacitor. That will be 400 multiplied by root 2. Multiply with root 2. So 400 root 2 is the correct option. Is this clear? Is this clear? Okay, now let's move on to the next one. Okay, this is the question from EMI portion. This is the question from EMI portion. Now guys, take a look, take a look. Find the induced current. Find the induced current at A, B, C, and D. This loop is basically moving inside this magnetic field. This magnetic field is uniform. Okay, this is uniform magnetic field. Uniform magnetic field. So whenever a loop enters the uniform magnetic field, or whenever the field through the loop changes, we say current is induced in the loop. We have to find the direction of that induced current. Guys, see, we say when it is outside, no field line is crossing the loop, so current outside is 0. While it is moving in, as it goes in, we say more number of field lines are crossing. As it moves more inside, more field lines will cross. So if guys, see, at A, I'll write over here, at A, can I say magnetic field, this primary magnetic field is increasing? Yes. Primary magnetic field through the loop is increasing. And my dear friends, always remember, if magnetic field through the loop increases, it will oppose that magnetic field. It will create an secondary magnetic field. We say secondary magnetic field if it is increasing and it is inwards. If it is increasing and it is inwards, secondary magnetic field will be outwards. Okay, because this Lenz's law says that if the magnetic field through the loop is increasing, loop will oppose that increasing magnetic field. If it is decreasing, loop will support that decreasing magnetic field. So I can say secondary magnetic field will be outwards. Okay, secondary magnetic field will be outwards. This is B secondary. Sir, it is only possible if the direction of the current is anti-clockwise. How? Curl your fingers along the direction of current, thumb is pointing outwards. So I would say in this case, current is ACW. When the loop is completely inside, we say magnetic field through here, it is constant. When constant magnetic field crosses, so current will be 0. No current flows, current will be 0. Current will be 0. Okay. And guys, when this loop is coming out at point D, I would say, listen carefully. We say at D. Can I not say primary magnetic field? As the loop comes out, magnetic field through the loop decreases. So B primary decreases. B primary decreases. As the loop comes out, we say B primary decreases. As the loop comes out, we say B primary decreases. Okay. Now, my dear friends, if B primary decreases, we can say, and it is inward, It is decreasing and it is inward. So we say B secondary would be. What is the direction of B secondary? Guys, it is decreasing and is inwards. So B secondary will be also inwards. Why? Because Lenz's law says that if the magnetic field through the loop is decreasing, okay, the loop will support it. Okay, how do you support it? By applying the magnetic field in the inward direction. Okay, this is the B secondary. This is only possible if the direction of the current is clockwise. If the direction of the current is clockwise. So current is clockwise. Why? Because if clockwise current flows through the coil, curl your fingers along direction of current, thumb is pointing inwards, then only secondary magnetic field will be inwards. So at point A, current in the loop is 0. At point C, current in the loop is 0. At point B, current is anti-clockwise. At point D, current is clockwise. This one, important question. Coil A, coil B. Let's suppose in this particular case, you have got a coil. This is the observer. The magnet is moving away from the coil. Find the direction of the current in both the coils, in the coils. Find the direction of the current in the coil. See, guys, always remember this particular concept. That is, if you have a coil over here, always remember, if you have a coil over here, if there is a magnet, this is a magnet, okay, this is north and this is south. Okay, if there is a magnet, this is north and this is south. Okay, magnet has north pole, south pole. If this magnet is moving towards the coil, coil opposes the increasing magnetic field. So if it is moving towards the coil, this coil will oppose it. How will it oppose? It will create an imaginary bar magnet inside, which has south pole from this side, north pole from this side, okay, which will repel it. South pole repels south pole. Okay, one more case. If this is a coil, if this is the magnet which goes, away from the coil, this is north and this is south. If this magnet goes away from the coil, this coil will never want that the magnet should go away from it. So it will create an imaginary bar magnet. It will create south pole from this side, north pole from this side, so that this south will attract it. So basically, coil does not want magnetic field through should it either increase or decrease. So basically, coil does not want the magnet should come near to the coil. Coil does not want magnet should go away from the coil. Okay. So this is the scenario. Now see, take a look. In this case, this coil, this magnet is moving away from the coil. This coil will create an imaginary bar magnet inside. North pole will be from this side, south. Then only north will attract south. If it is moving away, then it will attract. If it is moving towards, then it will repel. Now it is moving near to this coil. It will also create an imaginary bar magnet. Okay. So north pole from this side, south pole from, then only it will repel. Okay. Now, there is a statement which you guys need to write. Remember, what is that? If observer sees north, pole of imaginary bar magnet, if observer sees north pole of imaginary bar magnet, then current is anti-clockwise. Then current is anti-clockwise. The next statement is, if observer sees south pole of imaginary bar magnet, okay, the current is clockwise. Now guys, see, if the observer is here, observer is able to see directly south pole, north pole is from another side. So current in this coil is clockwise. I is clockwise. When it comes to this, observer is directly able to see north pole. Current in this is anti-clockwise. Okay. Even you can form the question something like this also. You have a coil. Okay. You have this magnet south, this is north. You have another coil. You have the observer from this side. Now tell me, this is moving towards this. If it is moving towards that, here in this particular case, this will be north pole, this will be south pole. Your imaginary bar magnet will be created. This is north pole and this is south pole. Now take a look. This observer is able to see, south pole, Current in this will be clockwise. Okay. This observer is seeing north pole. In this particular case, current will be anti-clockwise. This is the simple logic that you guys need to use in every question. Okay. Now guys, take a look. Now guys, take a look. In a coil of resistance 10 ohms, the induced current developed by changing the magnetic flux, okay, through it, as shown in the function of time. Okay, this is the induced current. Current changes with time, something like this. There is a coil which has got the resistance of 10 ohms, and the current is changing with respect to time, something like this. The magnitude of change in flux, we are supposed to find the magnitude of change in flux. Guys, see, when it comes to the EMF, according to the Faraday's law says that EMF is d phi divided by dt. Okay, we can say over here d phi will be equals to EMF into dt. This is change in flux. Now integrate both sides. If you do the integration, it will be total change in flux, delta phi. It will be integration of EMF into dt. EMF will be I into R, because V is equal to I into R, Ohm's law, and dt. Now take this over here, delta phi will come out to be R, integration of I dt. What I want you to understand in this particular case is, guys, when you take a look at this I versus T graph, could you please tell me what is area of the graph? Area is always integration of I dt. Because if it was Y versus X graph, then I would have said area is integration of Y dx. Here it is IT graph, so it is area integration of this. Now, what is the area of this one? Guys, area of this is area of the triangle. That is 1 by 2 base. Base is 0.1. Okay, that is 1 by 10. Altitude is, we say, sir, 4. So 2 1s are 2 2s are 4, 2 1s are 2 5s are 10. So 1 by 5 is the value of what? Integration of I dt. Okay, because area we calculated, that is the value of I dt. Now put it over here, integration of I dt, put it 1 by 5. So I can write delta phi will come out to be R. What is the value of R? Resistance of the coil is given as 10. Okay, and this will be 1 divided by 5. 5 1s are 5 2s are. So delta phi in this case will come out to be 2. Answer is 2. It is 2. Answer is 2. Let's suppose we have this question over here. Find the induced EMF in a circular loop where radius R is much less than, capital R. Tell me the answer of this particular question, guys. Tell me the answer of this particular question. Okay. Okay. Find the induced EMF. Okay, now guys, take a look. This is a wire over here. In this wire, current is flowing. I is equal to I naught into T square. Now, due to this wire, magnetic field will be produced at R distance. Okay. Now, see guys, and how do you find the direction of that magnetic field? Place your thumb along direction of current, curl your fingers. So, when it comes to the magnetic field here, magnetic field will be inwards. This is the magnetic field. And how much is this magnetic field due to the wire? This is mu naught I divided by 2R. Due to an infinitely long wire, this is mu naught I by 2R. And you can write it like this, B is equal to mu naught I. What is the value of I? That is I naught into T square divided by 2R. Okay, yes. Now guys, if this magnetic field is crossing the loop, EMF will be induced in the loop. Yes, because whenever magnetic field lines cross the loop, EMF is induced. So I can say EMF in the loop will be minus d phi divided by dt. So you'll be writing it minus d by dt of flux. Flux means magnetic field into area. Magnetic field into area. So we'll be writing over here EMF is equal to minus d by dt of, what is the value of magnetic field? That is mu naught I naught t square divided by 2r. And what is the value of this area? Area in this particular case, that will be pi into small r square, because it is crossing this area, and this is the capital R. Okay. Now guys, in this particular case, what can you take common? Mu naught I naught you can take common, pi you can take common, small r square you can take common, because radius of this is constant, divided by 2r, and differentiation will be dt square divided by dt. Okay, and this negative sign. And if I write this EMF over here, I can say this EMF will come out to be, guys, that is mu naught I naught pi into r square, that is d by dt. This will be 2t divided by 2r. This 2 and 2 will cancel, so it will be minus mu naught I naught pi r square into t divided by this r. This is the final value of EMF that you get in this particular question. What about this one? A uniform magnetic field is restricted within a region of R. Okay. So magnetic field is present in this region R. The magnetic field changes with respect to time as dB by dt. This magnetic field is changing. In the loop 1. In the loop 1, R is greater than, this R is greater than, capital R is greater than small r. Okay. And in the loop 2, there is no magnetic field. Guys, we are supposed to find the EMF generated in the loop 1 and loop 2. Guys, when it comes to the EMF will be simply, we say EMF is equal to minus d phi divided by dt. Faraday says that if magnetic field or flux through the loop changes, EMF is induced. So you guys will say over here, this EMF will be minus d by dt of magnetic field into area, B into A. So you guys will write over here, EMF is equal to minus d by dt of magnetic field into area. Now I can write over here, guys, dB divided by dt. When it comes to the area, in the first case, you have to take that area in which magnetic field is present. Magnetic field is present in this area only, R. You will be writing pi into small r square. Okay. So my dear friends, I can say EMF in this case is, take this out, minus pi into small r square dB divided by dt. Okay, option first is matching, and 0 in the loop 2. Here EMF is 0. Why? Because magnetic field in this particular case is 0. No field line is crossing the loop, so magnetic field is 0. So that's why I'm saying first. And why did I take this radius? Because magnetic field is changing in this portion only. That's why. What about this one? Two identical long conducting wires AOB and COD. Okay. You have two identical long conducting wires AOB and COD are placed at a right angle to each other. Okay, are placed at right angle to each other. Something like this. Okay. This is AOB, and we say COD. Okay. With one above other, such that O is the common point. O is their common point for the two. The wires carry I1 current. Current in this is I1. Current in this is I2. Okay. It's in 3D, guys. Okay. Respectively. Point I is lying at a distance D. from O along the direction perpendicular to the plane. Guys, the plane of this is this. I'll tell you. This is the wire. This is another wire. Okay. This is the wire. This is another wire. When it comes to the plane, this is the plane. This is the plane. This is the plane of the two wires. And there is a point perpendicular to the plane of two wires at distance D. This point, this point. So means from here, you are supposed to go at distance D. You are supposed to go at distance D. This point, this is a D point. Okay. Okay. This is distance D. This is point P. Okay. The magnitude of the magnetic field at point P will be, you are supposed to say what will be the value of magnetic field at this point P. Okay, it is perpendicular. Now guys, see, magnetic field at this point will be due to this wire as well as this wire. Okay, so first and the foremost thing, when it comes to the net magnetic field at point P, sir, magnetic field due to this wire, magnetic field due to an infinitely long wire, that is mu naught I by 2 pi r, mu naught I by 2 pi r. Now, due to this wire, it is mu naught I1. Due to this wire, it will be mu naught I1 because current in this is I1 divided by 2 pi. And distance at which you are finding, that is D, so it is D. Now guys, what is the direction? Place your thumb along direction of current, curl your fingers, okay? It is in the outward direction, Z direction. So I will write over here, this is K cap. Z direction means K cap. It is outward, okay? Another magnetic field will be due to this. Then plus mu naught I2 divided by 2 pi D. What is the direction? Place your thumb along direction of current, outward. Curl your fingers. It is towards negative x-axis. I'll write over here minus I cap, minus I cap. So in this particular case, I can write net magnetic field as, guys, this will be mu naught I1 divided by 2 pi D into K cap minus mu naught I2 divided by 2 pi D into I cap. Okay. Now, if you want to find the magnitude, guys, how do you find the magnitude of two vectors? We say magnitude B net. It will be under root of this square, mu naught I1 divided by 2 pi D, its whole square, plus this square, mu naught I2 divided by 2 pi D, its whole square. Now guys, what you can take common, mu naught I divided by 2 pi D, mu naught I divided by 2 pi D will take common, its square and root will cancel, so it will come out mu naught by 2 pi D, mu naught divided by 2 pi D. And what remains inside? That is I1 plus I2. Whole root, instead of root, I'll put 1 by 2. And it's square, So I1 square plus I2 square whole raised power 1 by 2, mu naught I by 2 pi D. Option D is the correct one. This is a very important question. What about this? Find the net magnetic field at O. At this point O, you guys are supposed to find out the net magnetic field. At this point O, you guys are supposed to find out the net magnetic field. Okay. Guys, when it comes to the net magnetic field, just a second, guys. Tell me, guys, is it fine? Is it fine? Is it working properly now? Yes, that's great. Now, guys, Find the net magnetic field at O. In this particular case, you have got this semi-infinite wire, you have got semicircle, and you have got semi-infinite wire. Now, when I write the net magnetic field in this particular case, magnetic field, this will be magnetic field due to this 1, that is B1, plus magnetic field due to 2, plus we say magnetic field due to 3. Okay, yes. Magnetic field due to 1, magnetic field due to 2, magnetic field due to 3. Okay. Now, just a second. Now, in this particular case, guys, when it comes to the semi-infinite wire, we say magnetic field due to semi-infinite wire, that is mu naught I divided by 4 pi into R. Okay, mu naught I. I is the current in this one. Okay, I is the current in this one. I is the same current flowing over here, same current over here. Okay, so basically it's a structure something like this. It is going something like this is the wire entering, reaching the board, and then something like this, then again coming out. It's in 3D. So current is going in, then moving something like this, then comes out. Okay, mu naught I by 4 pi R. Now guys, it is mentioned over here, this is y-axis. Don't consider this as x-axis, this is y. This is z and this is x. Now what is the direction of this magnetic field? How do you find? Place your thumb along the direction of current. Since it is going inside the board, place your thumb along direction of current. Curl your fingers at this point. It is downward. So it is z-axis, so downward will be minus z. Minus z means minus k cap. Then magnetic field due to this, that is going to be mu naught I divided by 4R. Due to a semicircle, magnetic field is mu naught I by 4R. Okay. And what is the direction? We say curl your fingers along the direction of current. Thumb is pointing inwards. Outward is plus axis. Inward is minus x axis. So this will be minus I cap. Then again plus. What is the magnetic field due to this wire? So again it's a semi-infinite wire. It is going to be mu naught I divided by 4 pi R. And direction? Place your thumb along direction of current, curl your fingers, it is downward. So it is minus k cap. I would say it's something like this. So this will become 2 times, okay? 2 times. So minus 2 times mu naught I divided by 4 pi R. Okay, into k cap, and minus mu naught I divided by 4R into I cap. Okay, so this is going to be the net magnetic field in this particular case. What about this? Can you answer this question? Can you answer this question? Find the magnetic field at the center. If the length of the arc, find the magnetic field at the center. If the length of the arc is 2 pi r. Okay, if the length of the arc is 2 pi r. Okay, see. Consider this as an arc. What is the magnetic field due to an arc? We say magnetic field due to an arc. We say that is B is equal to mu naught I divided by 2R, and R means the radius. So I'll write small r over here. 2 into small r, theta divided by 2 pi. Theta means the angle of that arc. If I say, sir, this angle is 30 degrees, so this will be the arc over here. Yes. Now guys, tell me, could you please tell me how much will be this? This is the theta. This is the theta that we say over here. This is the angle. Okay. This is theta dash. Now guys, tell me in this particular case, this is angle upon this. Angle means this. Join this center with one end, join the center with another end. Angle between these two is what we call the arc. The angle between these two is what we call the angle. How do you define? How much is the total angle? 360. And how much is this theta? So can I say this theta is going to be, 360 minus theta? Yes. Divided by 2r. This will be 360 minus theta divided by 2 pi. 360 minus theta divided by 2 pi. 360 minus theta divided by 2 pi. Okay, yes. Now, tell me one thing, guys. So we say magnetic field in this particular case. Magnetic field in this particular case. This is 360, okay? Or 2 pi. Don't write 360, write 2 pi. 2 pi minus theta divided by 2 pi. Okay? Now, in this particular case, tell me, guys, tell me. When I say this R, could you please tell me, I can use this particular formula. Angle is equal to arc upon radius. Yes. So can I say this radius R will be arc upon arc? What is the value of arc? They have given in the question value of arc is, that is 2 pi into capital R. Value of this arc is given in the question 2 pi capital R divided by radius. Okay. This is arc, which radius is arc upon angle. Angle is given as 2 pi minus theta. 2 pi minus theta. Now put this over here. So you'll be writing B is equal to mu naught I divided by 2 into. What is the value of R? That is 2 pi into capital R divided by 2 pi minus theta. And here you have 2 pi minus theta divided by 2 pi. Now guys, if you take this in the numerator, it will become whole square, 2 pi minus theta whole square. And 2 pi becomes 2 pi whole square. See, I can reshuffle it. I can write it like this. Mu naught I divided by 2R, capital R, okay? Then we can write this as 2 pi minus theta divided by 2 pi, its whole square. This is the answer to the question. This is the answer to the question. Small r was not given in the question. That's why. That's why. Okay. Okay. What about this? A proton and an alpha particle accelerated through the same potential difference enters in a region of uniform magnetic field. Enters in a region of uniform magnetic field. Okay. With their velocities perpendicular to the field. Compare the radii of the circular paths followed by them. Guys, see. It says that you have got a magnetic field over here. You have got a magnetic field over here. Okay. In this magnetic field, a proton is entering. Okay, proton has got a charge. It will perform the circular motion. Okay. And an alpha particle is also entering. Alpha particle also has the charge. It will perform the circular motion. Because we know when a charge enters the magnetic field perpendicularly, it performs the circular motion. Okay, it performs the circular motion. So this is the circle made by the proton. This is the circle made by the alpha particle. Okay. Then it says that radius of this is, let's suppose RP. Radius of this is, let's suppose R alpha. Okay. Compare the radii. We are supposed to compare the radii of the two. Guys. Tell me one thing. When a charge enters the uniform magnetic field, what is the radius? How do we find this radius? Sir, radius is mv divided by qb. Momentum divided by q into b. Q is the charge. B is the magnetic field, M is the mass of the charge, V is the velocity. Okay. This is the radius. Now guys, tell me one thing. We say as. When it comes to the kinetic energy, we say kinetic energy is 1 by 2 mv square. Multiply with m and divide with m. So kinetic energy will come out to be m square v square divided by 2m. Now take this 2m over here. So this will be 2mke, okay, is equal to m square v square. Take this square over here, it will become root of 2mke is equal to m into v. So instead of m into v, I'll be directly writing over here r is equal to under root of 2m into kinetic energy divided by qb. Now guys, the charge which they are given over here is proton and alpha particle. Okay. Now guys, see. When it comes to the proton, when it comes to the alpha particle, charge on proton is E, charge on alpha particle is 2E. Mass of proton is M, mass of alpha particle is 4M. Keep this thing in your mind. Because alpha particle is made up of 2 protons and 2 neutrons. Alpha particle is made up of 2 protons and 2 neutrons. Okay, that's why it has got charge 2E and mass 4M. Now, in this particular case, we say kinetic energy of both is same, okay, accelerated through the same potential difference. Okay, then you can write the formula something like this. Under root of 2m q delta v. Because kinetic energy we can further write as q delta v. It is given as potential difference divided by qb. Now guys, potential difference for both the charges is same. Delta v is same, okay. Magnetic field for both is same, constant. Now, can I say this radius? Radius will only depend upon. We say mass and this charge, that is under root of m into q divided by this q. Only these 3 terminologies, yes. Rest are constants. What I want you guys to do is multiply with root q and divide with root q, okay. Now, this root q into root q is q. It will cancel with this q. Now, here it is root m, root q. R will be proportional to under root of m divided by q. This is the final relation. Now, R will only depend upon mass and charge. Now, if we say radius of proton, guys, we say radius of proton divided by radius of alpha particle. It is going to be under root of m by q. Mass of proton is m, charge of proton is e, upon under root of mass of alpha particle is 4m, mass charge of alpha particle is 2e. So I can write radius of proton divided by radius of alpha particle. It will be a root m divided by e multiplied by 2e divided by 4m. This 2 ones are 2 2s are 1 divided by a root 2. 1 divided by root 2 is the correct option. Is this clear? Is this clear? Tell me. One more question you are given over here. The magnetic field existing in a region is given by B is equal to the magnetic field existing in a region is given by B is equal to B naught x by L plus x square by L square. Okay. So this is the region in which magnetic field is given. B naught x square by L square, x by L plus x square by L square into k cap. A square loop of edge L carrying the current I, okay, this is a square loop, it is placed in the same magnetic field. You are supposed to find the magnetic force experienced by the loop. Guys, find the magnetic force experienced by the loop. Always remember, if we place a square loop, okay, or a circular loop in a constant magnetic field, the net force on the loop is 0. But here, magnetic field is not constant, it is variable, it changes with x. Okay. Magnetic field is not constant, it is variable, it changes with x. Now guys, take a look. See. We say, could you please tell me, whenever a wire is placed in the external magnetic field, let's suppose this is the external magnetic field. In this external magnetic field, you are placing a wire. It has length L, it has current I in this one. What is the force on this wire? Force is IB into L. Bil, B-I-L, bil. Okay. Now guys, see, First and the foremost, let's talk about the force on this wire, Here, what is the value of X here? X is 0. What is the magnetic field at this point? Guys. Magnetic field at this point will be B is equal to B naught. What is the value of X at this point, where this rod is placed? That is 0 divided by L plus 0 divided by L. So 0, okay, into this is 0. So magnetic field will be 0. Here magnetic field is 0. If magnetic field is 0, what about magnetic force? 0. So means force on AB part. Force on AB part is 0 because magnetic field is equal to 0 at this point. Okay. Now guys, see. When it comes to the BC, okay, this portion of the wire, how do you find the direction of the wire? See guys. Sorry, direction of force. Place your thumb along the direction of current. Okay. Place your thumb along direction of current. Curl towards magnetic field. This magnetic field means outward, dot. Thumb is upwards. On this is the force. Now, here, place your thumb along the direction of current. Curl towards magnetic field. Thumb is downwards. So, force on this portion is downwards. Force on this portion is downwards. So, this force and this force will be equal. So, this force is cancelled with this force. So, I would say force on CB part will be equals to the force on, we say AD part. Okay. So this force and this force will cancel. Okay. They are equal and opposite. Now what remains over here? This. Now force on CD part. Okay. Force on CD. Force on CD portion of the wire. Guys, if you have to find the force on CD portion of the wire, I want you to understand this particular point. Okay? I want you to understand this particular point. See, at this length L, we say magnetic field at L length, L distance. How can we write this magnetic field? B is equal to B naught. Then I say L by L, L divided by L plus L square by L square, because instead of X, we will be putting X. What is the value of this wire? This wire is placed at what distance? X is equal to L. So now this is 1 plus 1 is 2. So force, magnetic field will come out to be 2 times of B naught. Now tell me force is equal to BIL. Instead of B, you write 2 times of B naught, IL. Is this clear? A conducting loop carrying a current I is placed in a uniform magnetic field pointing into the plane of the paper as shown in the loop. The loop will have the tendency, as shown in the figure, the loop will have the tendency to expand. Why? Because if this is a loop, guys, see, if this is a loop, okay, magnetic field is given as inward. Direction of the current is this is I. If you want to find the direction of force, see, magnetic field is inverse. Take this small portion of the loop here. Place your thumb along direction of current, curl towards magnetic field. Thumb is upward. Your force is acting in the upward direction. Your force will be acting in the outward. So if a force is outward, so loop will expand. Loop is going to expand. Is this clear? Tell me, guys. Force is going to expand. Okay. Guys, let's take a break of 15 minutes. So right now it is 4:48. We say 5:5. Break till 5 p.m. Okay. We have some questions. It will take like 1 hour. We'll have to complete it. Let's take a look, guys, in this particular case. A short bar magnet, okay, of magnetic moment, this is the magnetic moment, 0.32 joule per Tesla, is placed in a uniform magnetic field of 0.15 Tesla. If the bar magnet is free to rotate in a plane of the field, then which orientation would correspond to its stable and unstable equilibrium? And what is the potential energy in each case? Guys, it is simple. When it comes to the potential energy, when it comes to the stable equilibrium, we say when theta is equal to 0 degrees, it is called stable equilibrium. Means, let's suppose if this is the magnetic field, and in this magnetic field, if you are placing a bar magnet, this is the bar magnet which you have placed in the magnetic field, and this is the magnetic moment of the bar magnet. Angle between M and B is 0. In this particular case, you say potential energy is minus MB cos of 0 degrees, minus MB cos theta. Potential energy of a bar magnet or a dipole placed in an external magnetic field, that is minus MB cos theta, where M is the magnetic moment, okay, and B is the magnetic field, cos 0. So here potential energy is going to be minus MB, okay. And similarly, my dear friends, when it comes to the unstable equilibrium means, and this will be over here pole strength, it is minus M, and this will be plus M. It is always from minus M to plus M. And when it comes to when theta is equal to 180 degrees, okay, my dear friends, this is what we call unstable equilibrium. This is called unstable equilibrium. So means if you have magnetic field something like this is the magnetic field in the forward direction, and you have placed a dipole such that this is minus M, this is plus M, okay, north pole and south pole. In this particular case, this will be the dipole moment. What is the angle between M and B? That is 180. In this case, we say potential energy will be minus MB cos of 180. Cos 180 is minus 1. Minus into minus is plus. You will come out to be plus MB. Now put the values. 0.32 multiplied by 0.15. That will be the potential energy in case of stable. Here it will be negative. Here it will be positive. See, two galvanometers, A and B require current of 3 milliampere and 5 milliampere respectively, to produce the same deflection, Guys, see, when it comes to the equation of galvanometer, we say NIAB is equal to C theta. This is the equation of the galvanometer. Now, if I say here, theta divided by I, divide this I with theta, it will come out to be NAB divided by C. It will come out to be NAB divided by C. This theta divided by I is what we call the sensitivity of the galvanometer. Okay. Theta is the deflection, I is the current. Now, guys, in this particular case, it says that both galvanometers A and B, they are having the same deflection, means theta is same. Theta they are mentioning over here, I naught. Theta is same. So this sensitivity of galvanometer is inversely proportional to current. So can I say sensitivity of galvanometer A divided by sensitivity of galvanometer B, it is going to be 1 by I, that is 1 by 3, for this one 1 by 3 upon 1 by 5. So that is going to be 5 divided by 3. Now if I say sensitivity of galvanometer B will be equals to 5 by 3 times, okay, or 3 by 5 times. 3 by 5 times galvanom sensitivity of A. Okay. Or directly you can say over here, the one which has got more current will have less sensitivity. So which one has got more current? B. So it will have less sensitivity. Okay. Okay. So B will have less sensitivity. So A is more sensitive than B. Okay, because SI is inversely proportional to I. Now guys, let's move on to the next one. Okay. This is the question from drift velocity concept. This is the question from drift velocity concept. Where wire carries a current of 1.6 ampere. Okay. Current in the wire is given as 1.6 ampere. If 3 electrons per meter are, means number of electrons per meter, 3 electrons per meter are 2 into 10 raised power 24 per meter. Calculate drift velocity. Guys, see, when it comes to the formula, we say I is equal to NEAVD. Okay. Here I can say, in this particular case, here I can say, when it comes to the drift velocity, it is I divided by NEA. What is this N? N means number of free electrons per unit volume. N means number of free electrons per unit volume. And how do we write this as? This is total number of electrons divided by total volume, that is A into L. Volume means area multiplied by length. Now, if you put it over here, if you put it over here in this, so you'll be writing this VD, you'll be writing this VD will come out to be I divided by, instead of N, you'll be writing N divided by A into L. Then we say E into A. This and this will cancel. So it will come out to be I divided by N by L into E. Now, what is this N? This is total number of free electrons per unit length. Number of free electrons per unit length. Now, value of N by L. This is given as value of N by L. Number of free electrons per unit length. So I can say in this particular case, drift velocity will be I divided by N by L. What is the value of N by L? That is 2 into 10 raised power 24. Okay. And then we say charge on an electron 1.6 into 10 raised power minus 19 coulomb. Okay. Okay. And current in this particular case is given as 1.6 ampere. Solve it and get the answer. This is how we calculate if number of free electrons per meter are given. And if it was mentioned number of free electrons per unit volume, like 2 into 10 raised power 24 per meter cube, then directly put the value of N as 2 into 10 raised power 24. First, we'll solve this. Tell me, in this particular case, what I'm trying to say is that you have got voltage versus current graph, something like this. Okay. This is wire 1, this is wire 2. Now, guys, in case of Ohm's law, everybody of you must know that when it comes to the Ohm's law, we say V is equal to I into R. Okay. Okay. And I say here in this particular case, I is equal to, or we can say R is equal to V divided by I. Okay. This is according to Ohm's law. Now, if I ask you what is the slope of this graph, you say, sir, slope in this particular case will be perpendicular by base. That will be also V divided by I. This is equation second. Now, from first and second, V by I, can I say R will be slope? Yes. Slope is directly proportional to resistance. Slope is directly proportional to resistance. In case of V versus I graph, we say slope is directly proportional to resistance. Okay. Now, guys, I want you to understand one thing. What is that? That is, listen. Slope is directly proportional to resistance. Slope is directly proportional to resistance. Okay. Now, guys, which of the two has got more slope? Sir, this wire has got more slope. Okay, this is first. This is second. I can say in this particular case, slope of first is greater than, we can say, slope of second. So can I say resistance of first is greater than resistance of second? Yes. Now, guys, always remember resistance is proportional to temperature. If you increase the temperature of a resistor or a wire, we say vibrations will increase. If vibrations will increase, we say resistance is going to increase. Okay. Electrons will face more collision. So I can say in this particular case, temperature T1 is greater than temperature T2. Okay. Now guys, take a look at this question. Yes, this one. Here it is I versus V graph. Always remember, in case of I versus V, we can say resistance is inversely proportional to slope. And in case of VI graph, resistance is directly proportional to slope. Here resistance is inversely proportional to slope. So the one which has got more slope will have less resistance. Now, which has got more slope? Here. Slope of 1 is greater than slope of 2. So I can say in this case, slope of 1 is greater than slope of 2. So I can say resistance of 1 is less than resistance of 2. Resistance of 1 is less than resistance of 2. So can I say the one with less resistance will have less temperature? So temperature of 1 is less than temperature of 2. Next. See guys, if let's suppose you have got a conductor something like this, you are supposed to compare the current density and drift velocity at A, B and C and D. Guys, always remember, if this is a neutral current, whatever is the current at A, same will be the current at B, same will be the current at C, same will be the current at D. If it is a neutral conductor, we say current at every point will be same. Current at every point will be same. Okay, yes. Why? Because we say if let's suppose 10 electrons are crossing A, those 10 will also cross B. It is not possible, sir. 15 will cross B. 10, if 10 are coming, 10 will leave. So 10 will cross C, 10 will cross D. Here they will cross fastly with a large speed. Why? Because it's narrow. Here they will move easily, okay, with less speed. Now guys, in this particular case, current is same. What about current density? We say current density is current divided by area. Now, when I say current at every point is same, so current density is inversely, so current is constant. So current density is inversely proportional to area. So the point where area is large, current density will be less. So I can say, guys, the large current density, we say in this particular case, J is inversely proportional to A. J is inversely proportional to A. The point where area is more, current density will be less. Can I say current density at C will be less than, current density at B will be less than, current density at A will be less than current density at D? Yes, this will be the order. And when it comes to the relation between current density and drift velocity, we say J is equal to NEVD. This is the relation between current density and drift velocity. We say J is directly proportional to drift velocity. So whatever is the ratio of current density, same will be for drift velocity. So means VC is less than VB is less than VA is less than VD. Keep this thing in your mind. Now see, find the resistance of the concentric cylinders in the given figure. Guys, this is the concentric cylinder, and we say current is only flowing through this portion of the cylinder. Current is flowing through this portion of the cylinder. Okay. Inside it is hollow. No current is flowing from the inner side. Inside the cylinder, it is hollow. Inside the cylinder, it is hollow. Keep that thing in your mind. Inside the cylinder, it is hollow. So inside current is 0. Inside current is 0. Okay. Now guys, in this particular case, I would say, what is the complete radius? The whole radius is 3r. And what is the radius of inner portion? That is r. Could you please tell me which portion will create the resistance over here? Only this portion. Only this portion will create the resistance. Only this portion. Okay. And I can say the portion which creates the resistance will be the area which produces the resistance. In this particular case, when it comes to the area which is going to produce the resistance, that area will be, what is the whole area of this cylinder? That is, I would say, pi r square. R in this particular case is 3r whole square. And what is the hollow portion? Hollow portion is this much, pi r square minus pi r square. So pi into 3r whole square minus pi r square means you'll be getting this area. You'll be getting this area. Okay, so that will be 9 pi r square minus pi r square. So this is 8 pi r square. So basically this portion, this area only will create the resistance. Only this area will create the resistance. Now tell me, guys, what is the resistance, value of resistance, or rho L divided by A? Length of this is L, so rho L. Area, you have to take that area only, which will create the resistance, and that is 8 pi r square. So this portion will only create the resistance. That's why I'm writing over here rho L upon 8 pi r square. Okay. Now this is the question which was asked in NEET 2018, and this is the question which was asked in NEET 2021. Now guys, in this particular case, here it is grounded, here it is grounded. We have to find the value of this resistance R that is given over here. In such questions, what we do is we select the path. Let's suppose we are selecting the path from A to B. If you are selecting the path, select the path from A to B, from A to B. Select the path from A to B. If you are selecting the path from A to B, first you will write the potential of A, that is 0 volts, okay? Okay. Then, while moving from A to B, we always say current flows from higher potential to lower potential. So this is positive and this is negative. So if you are going from higher to lower, you take its potential drop as negative, okay? And how do you write its potential drop? How do you write its potential drop? V is equal to I into R. Current is 1 ampere, R is 2. So that will be 2 into 1 is, that is 2 volts. So for this, it will be minus 2 volts. Why? Because you are going from higher potential to lower potential. Then in case of this battery, you are going from lower to higher. So you will be taking its potential drop as positive, that is 12 volts. Then here, this is positive and negative. Its drop will be negative, that is I into R, 1 into R, that is R. Here, this is positive, this is negative. You are going from higher to lower. This will be also 4 into 1, that is 4 volt, is equal to 0, is equal to 0, is equal to 0, is equal to 0. Okay. Now, my dear friends, we say minus 4 minus 2, that is going to be minus 6 plus, this is 12, okay, minus R. Okay, this is plus 6, this will be plus 6, and this is 0. Okay, this will be is equal to R. So R will come out to be over here, that is 6 ohm. This resistance that we got over here is basically 6 ohms. Next, what about this question? What about this question, guys? What about this question? See, in this case, also select the path. First, we'll write the potential of A, that is VA, that is V. Okay, you have to find this potential only. Now, this is the direction of current. If this is the direction of current, this will be positive, this will be negative. This will be positive, this will be negative. Now, you are moving from lower potential to higher potential. So you'll be taking this drop as positive. So I into R. Current is 5 into 4 is 20. Then this will be minus 6 volts. Why? Because you are moving from higher to lower. So that's why I'm taking this as negative. Here, you are moving from lower to higher. You'll be taking this as positive. I into R. I into R. Current is 5 into 3 is 15. Okay, this is 15. And this is plus 15. Okay, then this you will be taking as plus 1 volt. Why you are moving from lower to higher? Is equal to VB. VB is equal to 0 volts because it's grounded over here. Okay. Okay. Solve this and get the value of V. What about this one? What about this one? Find the equivalent capacitance. Find the equivalent resistance. Resistors are given, so resistance. Find the equivalent resistance. Okay, guys, when it comes to the equivalent resistance in this particular case, these three are in parallel. Okay, whenever the resistors are in parallel, we say their equivalent resistances are by n. So that is 30 by 3. How many? 1, 2, 3. So 30 by 3. So if I say their equivalent, resistance, that is going to be 30 by 3, that is 10 ohms. Okay, let's redraw this particular diagram. You have got over here 10 ohms. This is 10 ohms. Okay, then you have got 20 ohms. This is 20 ohms. 10 plus 20, this is 10. This is 20. Sir, what about this? Here, potential across the ends of the resistor is same. So it will short circuit, SS, removed from the circuit. Even this will also short circuit. Why? Because it is connected directly, something like this. Potential across the ends is same, so it will short circuit. Now, which one is remaining? So 10 plus 20 I have made over here. This 10 and 20 I'll make over here. This is 10, this is 20. Now, how much is this? 20 plus 10 is 30. 20 plus 10 is 30. So 30 by 2. So R equivalent in this particular case is 15 ohms. Solve this first. Tell me, guys, what about this one? What about this one? Find the equivalent resistance. Guys, in reality, if we draw it, it is something like this. This and this is in series, 7 and 6. 7 and 6 ohm is in series. 7 ohm and 6 ohm is in series. 2 ohm and 5 ohm is in series. 2 ohm and 5 ohm is in series. Okay, this is 13. Now, R equivalent in this particular case is, this is 7 plus 6 is 13. Okay, this is 5 plus 2 is 7. So it will be 13 into 7 upon 13 plus 7. Why? Because R1, R2 upon R1 plus R2. Solve it and get the answer. What about this one? This is very important. You guys are supposed to find the current in this branch. Tell me, how do we find the current in this branch? Guys, see. Let's first do one thing. Let's resolve this entire circuit. 6 and 12 are in series, parallel. What is the equivalent of 6 and 12? It will be 4. Okay, it is 4. So equivalent of these two is 4. What is the equivalent of 12 and 4? It is 3. Now, what is the net resistance? 4 plus 3 is 7. So it is something like this, 7 ohms. And then you have got 70 volt battery. In reality, equivalent of all of these is how much? 7, and battery is 7. Battery is 70. Now, what is the net current in the circuit? I is equal to V by R, 70 by 7. So that is 10 ampere. So means battery is sending how much current in this case? That is 10 ampere. First, you should be able to find out the net resistance. Then you would be able to find out the current. Okay. Now, guys, use the law of current distribution. What does current distribution say? As current is inversely proportional to resistance. Okay. Where there is more resistance, current in that will be less. Here, if 10 ampere is entering, here resistance is less, current will be more. Here resistance is more, current will be less. Let the current in this is X. In this, how much will be the current? If 6 is how many times smaller than 12? 2 times. So this will be 2x. Or we say 12 is 2 times bigger than 6. 12 is 2 times bigger than 6. Now see, guys, we say 10x is entering over here. It is getting distributed in x and 2x. So x plus 2x. So we'll be saying 3x. So x will be equals to 10 by 3. So current in this is 10 by 3. Current in this is 10 by 3. And current in this is 20 by 3 because it is 2x. So that is 20 by 3 ampere. You got the current in these two branches. Now, the amount of current which enters will be same as the amount of current which leaves. Here also it will be 10. Now, see, use here also law of potential drop in this particular case. Okay. Guys, here if you use law of potential drop, we say, let's assume the current in this X. 4 is how many times smaller than 12? 3 times. 4 threes are 12. So in this, it is going to be 3x. Can I say here, x plus 3x will be equals to 10 ampere. This current plus this current will be 10 ampere. Now, if this is 4x is equal to 10, x will be equals to 10 divided by 4. Okay. And now, when we talk about 4x, it will be 40 divided. Okay, x will be 10 by 4. And what is 3x? Okay, we need only this one. X will come out to be 10 by 4. So this is 10 divided by 4 ampere. Okay, 10 divided by 4 ampere. This is 20 by 3. This is 10 by 4. Now, guys, if 20 by 3 ampere is coming from this side, it is getting divided into I and this 10 by 4. So can I say 20 by 3 is getting divided into I plus 10 by 4? So we say 20 by 3 minus 10 by 4 will be equals to I. Okay. Now tell me in this case, guys. We say do the cross. 4 and 20 is 80 minus 30 by 12 is equal to I. 80 minus 30 is how much? 80 minus 30 is how much? That is 50 by 12. So 50 divided by 12 will be the current. So in this branch, current will be 50 by 12. What about this one? Hello. Okay. मैं मकलो. No. What about this question, guys? What about this question? Find the current in the circuit. Guys, it is 0 volts over here. So here also it will be 0 volts. Here also it will be 0 volts. So remove this. Now, why? Because it will be short circuit. Potential across the ends is same. In this particular case, we say what will be the net? I will be equals to V by R. 10 divided by R is 1 plus 3 is 4. 4 plus 6 is 10. So 10 by 10, that is going to be 1 ampere. Okay. This one. Okay, what about this? Find the potential difference across AB. Guys, first and the foremost thing, what is the equivalent resistance of these three? It is 10, 30 by 3. So I'll make it like this. So this is 30 by 3, this is 10, and this is 15, and this is 5. I'll make, and this is the battery, 3 volts. Now use the law of potential drop concept. Law of potential drop says V is directly proportional to R. The one which has got large resistance, okay, will have large potential drop. If I say across this it is X, across this it will be 3X, across this it will be 2X. Because this is how many times greater than this? 2 times. Now, can I write over here this potential plus this potential plus this potential will be 3 volts. 3 plus 2 is 6 plus 3 plus 2 is 5. 5 plus 1 is 6. 6x is equal to 3 volts. X will be equals to 3 by 6. That is 1 by 2. That is 0.5. We are supposed to find the potential drop across AB. That is this. AB. That is 2x. So 2x will be equals to 2 into 0.5. That will be 1 volt. Okay. Now this question I'm giving you homework, and there are some more questions that I'll show you in the next question. Next one. Okay. Okay. So that is all for today, guys. Thank you. See you guys in the next session. Till then, bye bye and take care. Okay, we are done with this. Chalo, thank you guys. Take care. Bye bye. See you guys in the next session.